Hi guys, Assalamu alaikum. I hope you're all doing great. Today we will be solving some of the most important, difficult, and commonly asked questions from Edexcel level Physics Unit 1 to help you prepare effectively for your upcoming sessions. Let's get started. Alright guys, so now let's solve this question. It says a student of weight 600 Newton is standing on the weighing scale in a lift. Okay. The scales are calibrated to give readings in newtons. Okay. The lift moves upwards at a constant velocity, then decelerates to rest. So basically, first of all, it was moving with a constant velocity and then it decelerated. As the lift moves, the student looks at the reading on the scale. Explain the reading on the scale. This is a very repetitive question. Before solving this one, I will want to show you some supplements, that some ideas that you will have to have. The idea is when you are standing on a weighing scale, we always think that the weighing scale is giving us our weight, right? We always think that the weighing scale is giving us our weight, but actually the weighing scale is displaying our normal reaction force. The weighing scale is actually displaying our normal reaction force. When we actually measure our weight at our home, at that time our normal reaction force is equals to the weight. That's why we get our actual weight. Despite getting our normal reaction force, the normal reaction force at that time is equals to our weight, and we get our accurate value. But when we are moving or accelerating or decelerating in a lift, when we are decelerating in a lift, okay, we will go into the deceleration part later on. But basically the thing is, the main information is the weighing scale always displays your normal reaction force rather than the weight. You guys can see here, I have written the note right here. It says when a standard on weighing scale, you push down with your weight, right? You push your weight downward to the weighing scale, and the weighing scale pushes back up with a normal reaction force according to Newton's third law. You can actually you guys can use an analogy here, right here, that you are giving your weight to the weighing scale, right? And the weighing scale is giving you the normal reaction force according to Newton's third law. The scale measures this upward normal force, not your downward force directly. Since in normal conditions, no acceleration, the normal force equals your weight, the reading correctly shows your weight. But when you are accelerating or decelerating at that time, it actually doesn't show your actual weight. Okay, it actually shows the normal force, because when you're accelerating or decelerating, your normal force is not equal to your weight anymore. Okay, analogy is that you give a downward force to the scale and the scale gives back an equal upward force to you, and this upward force is what the scale actually displays. Now let's go back to the question. The question says the lift moves upward at a constant velocity, then decelerates. We know when it is decelerating, we know that the weight is acting downward and the normal force is acting upward. So when does something decelerates while moving up? It only decelerates when, though the lift is going upward, if the direction of motion is upward, but if the resultant force is downward, if the resultant force is downward and the motion is upward, only at that time it decelerates, right? It only decelerates when the resultant force and the direction of motion is in the opposite direction. When the direction of resultant force and the direction of motion is in the opposite direction, only then something decelerates. Otherwise, if the direction of resultant force and the direction of motion is in the same direction, then it will accelerate. Now let's have a look at the mark scheme points. The mark scheme point says the force of the lift of the scale on the student is the reading on the scale. Okay, actually this is quite confusing. The thing is, the reaction force is the reading on the scale, the thing that I have shown you previously, that the normal reaction force or the contact force is the reading on the scale. When it was at constant speed, at that time the resultant force was 0, because at that time the weight was equals to the normal reaction force. The weight was equals to the normal reaction force when it was moving constant. But when it started decelerating, that means despite it motion being upward, its resultant force is downward. That's why it is decelerating, and the resultant force downward means the weight is the greater force, because weight is acting downward. The resultant force downward means the downward force weight is greater rather than the upward force normal reaction force. So at constant speed, the reading on the scale would be 600 Newton, exactly what he has. But as the lift decelerates, the reaction is less than the weight. We know the weight is greater and the normal reaction force is less because the resultant force is downward. That means the downward force, which is weight, is gonna be the greater force, and the upward force is gonna be the smaller force. As the lift decelerates, the resultant force downward on the student. That means as the lift decelerates, the reading on the scale will be less than 600 Newton because this displacement, this 600 Newton, which has been displayed by the weighing scale, is because of the normal reaction force. As the weight is now decelerating, now normal reaction force is small. It is not equal to the weight anymore. That's why it will be a lesser value than the 600 Newton of weight. Okay, we know when it is decelerating, the weight is greater than the normal reaction force, and weight was 600 Newton. So as the normal reaction force is less than the weight, now it will be less than the 600 Newton as well. So this is how we will actually explain this type of theoretical questions. All right, guys. So now let's solve this very important question of energy and motion in bungee jumping. The question says in a bungee jump, the bungee jumper falls from a high platform while attached to an elastic cord. The cord is also attached to a platform. The cord shows the bungee jumper down so that he comes to rest before reaching the ground. The fall can be divided into three stages. The stage one says the jumper is in free fall until the cord starts to stretch. Now we have to think about it. And the stage two says the cord is stretching. The cord will be stretching until the acceleration of the jumper will decrease to 0. And in stage 3 it says the cord continues to stretch until the jumper is momentarily at rest. So basically when it will be at rest, the cord will stop stretching. Until it is at rest, it will continue to stretch. Okay, so now let's go and look at what the question says. The question says explain in terms of work done how the kinetic energy of the bungee jumper changes during the 3 stages of the fall. Now we will have to actually answer the question in terms of the kinetic energy. Okay, so now let's go back to the question as well as the work done of the bungee jumper changes, how the work done of the bungee jumper and the we'll have to explain in terms of work done how the kinetic energy of the bungee jumper changes, so how its kinetic energy will change. Now let's have a look at the stage 1. In stage 1, the jumper is in free fall until the cord starts to stretch. So it is in free fall. It is in free fall means gravitational force is acting on it, right? The gravitational force is acting on it. Let's say this is the bungee jumper. At that time, the weight was greater and the tension was very small. Why the tension was very small? Because the cord hasn't started to stretch till now. It just have a very small tension right here. So as the weight is greater, that means the gravitational force is acting on the jumper and it is accelerating downward because the downward force is greater and the resultant force is downward. So we can say the kinetic energy is increasing. Why? Because that is as its acceleration as it is accelerating, that means its velocity is increasing, and if the velocity increases, the kinetic energy also increases. And we are not going to only answer about the kinetic energy, we will also have to answer on the work done as well. So the gravitational force is doing work on the jumper only, right? Because the man is accelerating. So our answer will be in stage 1. As the jumper falls freely, the kinetic energy of the jumper is increasing because work is done by the gravitational force. So the jumper is accelerating. Now let's talk about the stage 2. What does stage 2 says? It says the cord is stretching until the acceleration of the bungee jumper decreases to 0. That means the cord is now stretching. And when the cord is stretching, that means previously the gravitational force was doing work on the man only. But now as the cord is also stretching and going down, the cord is stretching. When the cord stretches, it moves downward, right? And it stretches. So that means right now the gravitational force will not only do work on this man, it will also do work on the cord as well to stretch it down, right? To stretch it down, gravitational force will be doing work on the cord as well. So now the kinetic energy of this man will increase, but at a decreasing rate. Why at a decreasing rate? Because now the work has not been on the work has not been done entirely on the man. The work has to be done on the um, cord as well to stretch it down. So that's why the rate at which it was increasing in stage 1 will not be the same as the rate in stage 2. The rate will decrease, but still the kinetic energy will increase. Let's say here the kinetic energy was increasing, let's say 10 meter per second squared. Okay, the velocity was increasing at 10 meter per second squared, but right now the velocity will increase at 8 meter per second squared. The velocity will increase but at a decreasing rate. Why? Because the work has to be done on the cord as well to stretch the cord down. So now we can explain it down that in stage 2 the kinetic energy of the jumper is increasing but at a decreasing rate. Why? Because the work is done on the cord as the cord stretches. Now let's move forward to the stage 3. In stage 3 it says the cord continues to stretch until the jumper is momentarily at rest. The cord continues to stretch until the jumper is momentarily at rest. And when the cord is even more stretching, the cord is stretching, it continues to stretch means it is stretching even more. And when it is stretching even more, at that time, the work done is equals to kinetic energy plus, let's say, the elastic strain energy. Why the elastic strain energy? The elastic strain energy is to stretch to when it stretches more and more, when the cord stretches even more and more, the elastic strain energy increases, right? So this work done has been done by the gravity. So the gravity was previously doing work on at stage 1. In stage 1 right here, it was only work done is equals to the kinetic energy. In stage 2, it is work done is equals to kinetic energy plus elastic strain energy. Here the elastic strain energy was, let's say, medium. That's why the kinetic energy was still increasing but at a decreasing rate. But now in stage 3, the work done is equals to kinetic energy plus elastic strain energy. Now this elastic strain energy has increased so much that this kinetic energy will decrease and it will become equal to the 0, and at that time the velocity will become 0 and it will momentarily come at rest, because the amount of work that the gravitational force can do is constant. So if the elastic strain energy become equals to the work done, or then the gravitational force will invest all of its energy, or will use all of its energy to do work on the cord to stretch it down. At that time, the kinetic energy that the man was getting will decrease and become 0, because the elastic strain energy to stretch the cord will increase so much. So now we can explain it in stretch 3. It says the kinetic energy of the jumper is decreasing the kinetic energy of the jumper is decreasing. Why it is decreasing? Because we know the work done by the gravitational force is constant, and as the elastic strain energy is increasing constantly, the kinetic energy has to decrease, because both of them will be equal. The work done on the car is at a greater rate than work done on jumper by gravitational force. It comes to rest because the total work done by gravitational force is equals to the stretching the bungee jumper. We know stretching the bungee jumper is elastic strain energy is equals to the work done by the gravitational force. That's why the kinetic energy becomes equal to the 0. Now this was a very common question, and these type of questions have been asked in several years. This was a 2021 January Unit 1 question, and the same type of question was repeated in another year as well, in 2024 October. This question they have said a student is about to do a bungee jump from a high bridge. The student is attached to the bridge by an elastic rope. The student jumps from the bridge and initially accelerates. The diagram shows the student at 3 different positions during the bungee jump. At position A, the distance fallen by the student is equal to the original length of the rope. So here, the distance that the student has fallen is equal to the original length of the rope. So when it is equal to the original length of the rope, and then it says the student is in equilibrium. In equilibrium means here the resultant force is 0, and here the rope has maximum extension. And when the rope has maximum extension, that means the tension is greater than the weight. And when the tension is greater than the weight on the man, that means the resultant force is upward. And when the resultant force is upward but the man's direction of motion is downward, that means it is decelerating. So this is how we will explain the three parts. Position 8 says the distance fallen the man is student is equal to the original length of the rope. We know at first weight is downward and the original length of the rope was there. Original length of the rope means the tension is there, but the tension is very small compared to that of the weight. The weight is greater. So we can say initially weight is greater than tension, so the resultant force is downward. So the person is accelerating. Now, between stage A and stage B, the student is in equilibrium. That means the tension of the rope will increase and become equal to the weight. At that time, the resultant force will be 0, because at that time tension will be equal to the weight. So for the tension to be equal to the weight, in stage 1 tension was less than the weight. So to become equal to the weight, the tension must increase, right? So you can say tension increases as the length of the rope increases. Between A and B, resultant force decreases, so acceleration decreases. At B, the resultant force is 0, so acceleration is 0, right? Now in the latter part, in point C, it says the rope has a maximum extension, and when something has a maximum extension, we can say now the tension is greater than the weight, and when the tension is greater than the weight, we can say the upward force is greater than the downward force. But as the person is going downward and the upward force is greater, we can say the resultant force is upward, and the resultant force is in the opposite direction to the direction of motion. Because the direction of motion is downward but the resultant force is upward, we can say it is decelerating. We can say below B, the resultant force is upward and the student decelerates. So this is how we are going to actually answer these questions, this type of bungee jumping questions. So make sure you are familiar with this type of questions in both the ways. The first way is kinetic energy and the second way is acceleration. Make sure you are revising both of them clearly, because these type of questions may come in your method. Alright, so now let's solve this question number 13, which is a very important moment question. It includes a very important concept that is questioned by Edexcel absolutely in every alternating years. So it might be in your exam as well. So please, let's go through this question. The question says a book of length L and weight W is positioned on a shelf as shown. State what is meant by the center of gravity. Now we know the center of gravity is something from which the entire body, the entire weight of an object appears to act. So basically this is going to be our answer, the point from which the entire weight of an object appears to act. So this is the center of gravity from where the entire weight of this book is going to act. This is going to be our weight. Now the next part of this question says there are contact forces at the two positions where the book touches the shelf. This is one position and this is another position from which in these two positions it is in contact, right? It is in contact in these two positions. The book is in contact with the shelf in these two positions, and we know the points from which something is in contact, the normal reaction force acts, right? So basically this is going to be our another normal reaction force position, which is going to be our R2, and let's say this is our normal reaction force 1. Now it says the book is moved at a distance x to the right as shown. So the book is already moved to the distance of x from this position. Let's say previously the book was into right on this side, book was to the right, and when the book was to the right, this position was right here, and this center of gravity would have been towards right, and this position would have been right here. So basically it was towards the left, my bad. So it was towards the left. So um, this position before was right here, and this center of gravity was right here, and this position was right here, because every part of it was towards the left, right? Because it was towards the left. Now as it has moved towards the right, it has moved towards the right. Okay, the next part says the magnitude of the contact force R varies with x. Sketch on the axis below the variation of R with x between 0 and L by 2. You should mark the maximum value of R onto the axis. So basically this is when it was x meters, when the book was x meters, um, when the book was x meters to the right of this edge. Okay, now it is said from 0 to L by 2, when the length will be L by 2. Now we can actually draw this down like this. We can actually compare it with a pivot right here. This is something right here. Let's say there is two pivots in these two positions. Okay, there is two positions, these positions. We know at that time the weight is acting downward, and the two normal forces are, sorry, at the two normal reaction forces are acting upward. The two normal reaction forces are acting upward. So we can say that R1 plus R2 is equals to our weight, right? The two upward forces are balancing out the downward weight force, or the downward weight actually. So we can say that as both of them are equal, we can say 2R is equals to weight, and R is equals to weight divided by 2. So it was right here like this, and this was the length of the seesaw. This was over. Now the question was talking about sketch on the axis below the variation of R, how the R will vary with x between 0 and L by 2. So when the x will be between 0 and L by 2. So at this moment x has a value, right? When will the x will have a value of 0? The x will have a value of 0 right here. Why? Because the pivot is at the edge. If the pivot was right here, then this position would have been the value of the x, right? The x is when right here, this is the value of x. But if the pivot, this pivot is right here, if this pivot is right here, then this would have never have any x values, right? So basically now it has a value of x because it has the pivot at the edge. Now about the x is equals to L by 2. Now they're talking about the x is equals to L by 2, and it will be L by 2 because this whole is an L. This as a whole is the L, and x will be L by 2 when the pivot will be at the middle. When the pivot will be in the middle. So now let's draw this down together. When the pivot is in the middle, at that time the weight will be acting like this. Sorry, my bad. The weight will be acting from this direction, from here actually, and there will be the normal reaction force from this position as well, which is equals to the weight. So we can say at that position R is equals to weight, R is equals to weight when L is divided by 2. At that time L is divided by 2 because the pivot is in the middle. L is divided by 2 means L into half. So the pivot is at the L is equals to half. The pivot is in the half position of the length, right? At the half of the length. Pivot is at the half of the length of the, and right here the pivot was at the edge. So the length was basically 0. The pivot from this position is L by 2, and this position is also L by 2. That's why it is called L by 2. So when the variation of R with x between 0 and L by 2. 0 is the actually the distance from the pivot to the edge of the book. So here from the pivot to the edge of the box is x is equals to 0 right here, and here from the pivot to the edge of the box is x is equals to L by 2. So when the x is equals to 0, at that time our normal reaction force was weight divided by 2, and when x is equals to L by 2, at that time our normal reaction force is R is equals to weight. So when x is equals to L by 2, our normal reaction force is greater because it is equals to the weight, and when x is equals to 0, rather than L by 2, it is the normal reaction force being equal to weight by 2. So here we can write the normal reaction force will be greater and the normal reaction force will be equal to the weight. And here in the smaller position, the normal reaction force equals to weight over 2. We can actually bring it a little lower position, at a lower position, at R is equals to weight by 2. They are talking about the X. So basically the graph will be like this. The graph will be like this. So at L by 2, at L by 2, it has a normal action force equals to the weight, and at L is equals to 0, it has a normal action force equals to the weight by 2. Okay, you can only write weight and weight divided by 2. Don't need to write R is equals to weight like this. You can only write like this, weight and weight by 2. This is the actual graph, how the graph will actually look. Okay, you can also write it down in a much better way. It will be like this. Yes, so this is how the graph will be. It was a bit tricky, but not that difficult to understand, but this is a very important part to understand. Okay, now the next part is also important because this is the question which sometimes they ask they maybe ask in every alternating years, because this is the most important and the most difficult moment question, though it is answerable, not that difficult actually. It says explain why the book will not remain on itself if the x is greater than L by 2. Now let's draw it down right here. Let's say this is my book, and if it is right this position, it is L by 2 distance away from the edge, right? This is the edge. This is L by 2 distance away from the edge. Now if it moves even further into this direction, this L by 2 will increase. Let's draw it down right here as well. If it has moved right here, let's say, now this distance is greater than L by 2. This is greater than L by 2. So now it has been, the distance has become greater than L by 2. So now there is a clockwise movement in this direction. That not like this actually. There will be a clockwise movement in this direction. As there is a clockwise movement in this direction, the book will not remain on the shelf, it will fall. It will fall on the right hand side. So we can write it down like this. The answer will be this is a 2 marks question, so you will have to write 2 lines for it. The answer will be there will be a net clockwise moment, and another point will be because the center of gravity is outside the edge of the shelf. The center of gravity is outside this edge of the shelf, right? This is the edge of the shelf. Center of gravity is outside the edge of the shelf. Now in this second line, you guys might have a question that how is this edge of the shelf? This can be explained from this picture actually, because if this book is right here, its center of gravity is right there, right? Now if it moves like this, now the pivot point is right here. And now if the pivot point is right here, the center of gravity is outside this edge of the shelf. Or you can also say outside this edge. This edge was right here, right? This edge of the shelf. The center of gravity is outside the edge of the shelf. So it will fall. It will not remain on the shelf anymore. So this is how you will have to answer this question. It was a bit tricky, and this information and this understanding is really important for you guys, because there might be a question of this type where they will be asking about this age and how, if the center of gravity moves from towards the left to the right, how it actually works. So make sure you have understood this completely and write extra notes on your paper in this position so that you guys can. Now let's solve another tricky multiple choice question. It says two objects P and Q are at the same position at time t is equal to 0 seconds. The graph shows how the velocity varies with time for each object. So basically at the starting, they were at the same point while starting. And the two graphs shows how their velocity was varying with time. This is for object P and this is for object Q. Now the question asks, which of the following statement describes the position of P and Q at t is equals to 4 seconds. All right. Now in terms of graphs, we will have to watch what quantities they have given us. They have given us a velocity time graph. And here in the velocity time graph, we are going to look at the area under the graph, right? We are going to look after the area under the graph, and we know in a velocity time graph, the area under the graph represents the displacement. Here as well, it will represent the displacement. And now if we look at this graph, from time 0 to 2 second, it was in the positive direction. So here the displacement was positive. And in the second point as well, into this graph, from second to the fourth second, the displacement was negative. So we can say it had the same positive and the same negative displacement. The area under these two positive and negative displacement is the same. You guys can look at right here. The area is the same. The area under the positive and negative displacement graph is the same. So we can say if anyone moves, let's say 2 meter to the right and again comes back 2 meter to the left, he is still in its initial position, right? Let's say this was his initial position. This was the initial position. And then he moved 2 meters to the right, and from that position he has moved again 2 meters to the left. So he is back to its initial position from which he started to move, right? So eventually his displacement was 0 because he moved the distance to which he moved to the right is the same distance to which he has moved to the left. So his overall displacement is 0. Now let's have a look at this graph. This graph also represents the displacement graph, but this graph is only in the positive axis. As it is in the positive axis, no matter whether its velocity is increasing at a decreasing rate or what, still it will have some positive displacement, right? It will have its positive displacement because its velocity is positive right here. So we can say it had some positive displacement, whereas it has displacement 0. It had a displacement of 0, whereas it had a displacement of positive. That means it had something, let's say plus 5, plus 6, anything, but it's a positive value. So the question says, which of the following statements describe the position of P on Q at t is equals to 4 seconds? Our answer is going to be D. Why our answer is going to be D? Because they have said Q is further from the initial position than P. Basically, Q is ahead of P because Q has a positive displacement. Let's say he has moved 5 meters, but his displacement is 0. He's still in its initial position. That's why Q is further from the initial position than P. And all the other questions, all the other answers are wrong. So now let's move forward to another question. Trolleys X and Y of masses m and 3m respectively are traveling at the same speed towards each other. So basically they're moving towards each other. The trolleys collide and move together. This is a very important part of this question. This is a very important part, that they are moving together. Now the next part says, which of the following statement is correct? The force of X on Y during the collision is greater than the force of Y on X. This is an absolute bullshit. This cannot be correct. This cannot be correct as well. Because according to Newton's third law, the force exerted by X on Y and the force exerted by Y on X is gonna be the same. The force that X will exert on Y is the same as the force exerted by Y on X. The magnitude of these two forces are the same despite their masses. This is a very important part through which teachers actually ask questions in Edexcel A-Level Physics Unit 1. So make sure you have a clear knowledge of this thing, that the masses actually doesn't matter. So A and B cannot be our answer. Okay. Now the part C says the speed of x after the collision is greater than v. V was its initial velocity. They are saying that the speed of x after the collision will be greater than its initial velocity before the collision. It cannot be the same. Why? Because we know according to Newton's third law, force is equals to mass into acceleration. No, this is actually according to the Newton's second law. What I'm saying, according to Newton's third law, the x is exerting force on y, and y is exerting the force of same magnitude on x. So we know force is equals to mass into acceleration according to Newton's second law. We know when they have exerted force after the collision, they are saying after the collision. So after the collision, we know they will move off together. So when they will move off together, the mass of the x and y will be together. And after the collision, the mass of the mass of x and y will be together. So basically we can say the mass will increase because they are now moving together. They are now moving together. X and y is now one mass as they are moving together. So as the mass has increased, their acceleration will decrease because they are inversely proportional. And as the acceleration has decreased, the speed will decrease as well. So basically after the collision, it will have lesser speed than v, and v was our initial velocity. So our correct answer will be D rather than this one being not correct. So our correct answer will be this one, the answer D. Hopefully you guys have understood it completely. A sportsman hits a ball with a bat. The ball leaves the bat at a speed of 37 meters per second at an angle of 53 degree to the horizontal as shown. So basically this is the angle. As it is at an angle, it will have horizontal component and vertical component. This is our horizontal component, which is going to be 37 cos 53 because it is within the angle, and this is going to be my 37 sine 53. This is my vertical component. Alright, they have asked us to figure out the horizontal distance traveled by the ball before returning to the height it was hit from. So basically they have asked us about the horizontal distance. So they have asked us to figure out the horizontal distance. We know the horizontal velocity. We know the horizontal velocity, or the horizontal component of the velocity. So we have the velocity and we have the distance. We know speed is equals to distance divided by time taken, right? We have the speed. We have to figure out the distance. So to figure the distance, we will have to figure out the time. Now let's figure out the time right here. So to figure out the time, you can either use vertical motion or horizontal motion. You can use either of them, but I will be here using the vertical motion. Okay, here I will be using the vertical motion. Now when I will be using the vertical motion, while using the vertical motion, I will have to use the vertical velocity. And we know in vertical motion, as it is a double motion, in double motion the ball goes up and then the ball comes down, and we know in vertical motion the acceleration is negative. In vertical motion the acceleration is negative, right? So if the vertical motion the acceleration is negative, let's write the formula right now. S is equals to ut plus half at squared, right? We know our displacement is going to be 0 because it, the height from which it was released, it has come to the same height, right? They have said returning to the same height. So as it has come to the same height, we can say our vertical displacement is 0. And as our vertical displacement is 0, is equals to ut, and when our initial vertical velocity was 37 sine 53t plus half into minus 9.81 t minus 9.81 t squared. right? Which can be written as 4.905 t squared minus 37 sine 53 t is equals to 0. Now if you make t the subject, okay, if we take, I'm not gonna do this math as a whole because this is very easy simplification. This is a very easy middle term that you guys can do, hopefully. The t values will be 0 and t cannot be 0, and the other t value will be 6.024. So now we have got our value of t, and we will put this t value right here. We will put this t value right here and figure out the displacement. And we know our distance is equals to speed into time. Speed was 37 cos 53 into time was 6.024, and the answer will be 134.14. And we know all the data provided was in two significant figures, so you cannot write the answer in three significant figure. You will write the answer in the same significant figure to the data provided. So our answer will be 130 meter and two significant figures. So this is our answer to this question, and this is a very important question because this is the question that is repeated more or less in every projectile motion questions, and in which students face a lot of issues. So make sure you solve this. A stone is projected horizontally from a cliff. The initial horizontal velocity of the stone is 3.8 meter per second. So we say this is the initial horizontal velocity. The initial height of the stone is 12 meter as shown. So the cliff from which the stone has been projected is 12 meter above the ground. So the question says calculate the horizontal distance from the bottom of the cliff to where the stone hits the ground. So basically this is exactly the same typical projectile motion question that comes in the exam. We have seen previously another example, right? In that example it was a double motion. The ball was moving up, then it was coming down. That's why we have taken the acceleration as negative, but right here the ball is only coming down, or the stone is only coming down, and it will accelerate. So we can write acceleration is equal to positive right here, and we know acceleration is gonna be equal to the gravity. And now here it was initially it had a horizontal velocity, but it had no vertical velocity initially. It had no vertical velocity initially, and they have asked us to figure out the horizontal distance, and we know the horizontal distance that they have asked us to figure out is the horizontal distance from the bottom of the cliff to where the stone hits the ground. Okay, so this horizontal distance is something that they have asked us to figure out. This is the horizontal distance that they have asked us to figure out. All right, we know to figure out the horizontal distance, we know like previously speed is equals to distance divided by time taken. Okay, speed is equals to distance divided by the time taken. We know our horizontal velocity. We just need the time to figure out the horizontal distance. And we know time can be easily figured out using the vertical motion. Now let's take the vertical motion just like our previous question. So here in vertical motion, what we will do is, we know the formula S is equals to ut plus half at squared, right? And we know our displacement here is 12 meter, but whereas in the previous question the displacement was 0 because it went up and it went down the same height, so the vertical displacement was 0. Now the displacement here is 12, and we know our initial vertical velocity was 0, and this as a whole will become 0. So our formula is half at squared now. So half in the acceleration is 9.81 into the t squared. Now our t value will be equals to root over 12 divided by half into 9.81, and we can multiply this whole time value with the speed or the horizontal speed to get our distance. So our distance is gonna be this value right here multiplied by this 3.8 meter per second horizontal velocity. So our correct answer will be equals to, let me calculate, it is going to be 5.9 meters. So this is basically our correct answer. Alright guys, so now let's solve this question. It says a stunt motorcyclist wants to jump across a river to land on the other side. So basically he wants to land on the other side of the river rather than falling on the river. The diagram shows the motorcyclist driving off a ramp at the edge of a river. The ramp is at an angle of 25 degrees to the horizontal, as you guys can see, and the height at the end of the ramp is 3 meter. The width of the river is 100 meter. So this 3 meter is the height of the ramp. The initial velocity of the motorcyclist is 35 meter per second. Calculate the horizontal and vertical components of motor cycle's initial velocity as it leaves the ramp. So basically we know this is 25 degree and this is the vertical component, this is the horizontal component, and we know the horizontal component is with the angle. The horizontal component is with the angle, so we can say it is 35 cos 25. This is the horizontal velocity, which is gonna be equal to 31.7 ms minus 1, and the vertical velocity is gonna be 35 sine 25 because it is without the angle, and it is going to be 14.8 ms minus 1. So our correct answer is going to be 31.7 ms minus 1 and 14.8 ms minus 1. Now moving on, it says deduce whether the rider lands on the other side of the river. The effects of air resistance can be ignored. Now this is a tricky question. How? Let's read it down. Now we know it was 3 meter above the river, right? The motorcycle was landed 3 meter above the rider. It was 3 meter above the river. So it will go and it will come down to this position. It will have a vertical displacement of 0. Vertical displacement of 0. And then when it will go down again, it will have a vertical displacement of negative vertical displacement, right? Because when it goes up it has a positive vertical displacement, and when it comes down it has a negative vertical displacement. Let's say the height to which it reached was, let's say, 10 meter while going up, and then when it come down it also covered minus 10 meter. That's why the plus 10 and minus 10 becomes 0. That's why it has a vertical displacement of 0 when it has reached the same height from which it was released. But if it now goes down from the same height it was released, now the vertical displacement is gonna be negative. And now if the vertical displacement is greater than 3 meter, then we can say yes, it has gone to the river, right? Because it was 3 meter above the river. And if the vertical displacement is greater than minus 3, then we will be able to say yes, it has gone inside the river, right? So now let's figure out the vertical displacement. So to figure out the vertical displacement, we have the horizontal component of velocity. As we have the horizontal component of velocity, and we also have the horizontal distance as well, which is 100 meter. So if we use them, we can figure out the time, because we know speed is equal to distance divided by time taken. So time taken is equals to 100 meter divided by 31.7 minus 1. So our time is gonna be equal to 3.15 minus 1. Now the next parts that we will have to figure out is we have to figure the vertical displacement, and we know S is equals to ut plus half at squared, and here we will figure out this vertical displacement, and we know our initial vertical velocity was 14.8, right, into t, which is 3.15, plus half into acceleration. We know in double motion the acceleration is negative, so minus 9.81 into the t squared, and the t squared is gonna be 3.15 squared. Using this, our displacement will be minus 2.1 meter. As this negative displacement is less than 3 meter, we can say it didn't go inside the water. It didn't go inside the water. As minus 2.1 meter, we can write actually 2.1 meter. 2.1 meter is less than 3 meter, so it didn't go inside the river. That means it landed on the other side, and that other side was within this 3 meter range, not less than that 3 meter range. Hopefully you guys have understood this. Now the next part says explain how air resistance would affect the jump. Now this is a very important question which is more or less common in every exam of projectile motion. This is another typical question that comes, not in every exam actually, but in most of the cases this is the question that they ask, how air resistance will affect. Now let's go through it. Let's think it of right here. Let's say you have gone right here, the ball is going up. Now if there is no air resistance, the ball will go up, but if there is an air resistance, the resistance will act in the opposite direction to the direction of motion, so it will be a resistive force. Now the ball has reached this height, right? Now when the air resistance is acting, the ball won't be able to reach this much height anymore. The ball's height will decrease. Why? Because the air resistance is acting now. Just because the air resistance is acting now, the ball's height to which it would have reached has decreased because there is a resistive force acting on it. So its time on the air will decrease. As it has traveled less, now its time will be less as well. Its time will be less as well. And another thing is, as it has, if it would have traveled like this distance, it would have landed right here, right? But now as it hadn't traveled like this, it had traveled only this distance, so it will travel like this. So now the horizontal distance is also small. So basically this is the thing that happens when there is a resistance acting. Your time in the air decreases because you don't reach the height you would have reached without air resistance. And also as you didn't reach the maximum height, your horizontal distance will be small as well. So we'll write it down like this. And the first point will be air resistance acts to oppose the motion of the motorcyclist. The second point is gonna be, so it decreases the time of the motorcyclist in the air. And the third point will be, so horizontal distance is radius. Don't write the horizontal distance like this, write it completely. I have written it like this to save my time and solve more questions for you guys. Now let's move on to the next question. All right, so now let's solve another typical projectile motion question. It says a ball falls through a vertical height of 0.60 meter before bouncing at point A on a ramp as shown. All right, so it is 0.60 meter above the ramp. Show that the velocity of the ball immediately before the bounce is about 3 meter per second. So immediately before the bounce, we know they have asked about the immediately before the bounce. We know right here when it had a height, it had gravitational potential energy, and immediately before bouncing, let's say right here, he will have his gravitational potential energy converting into the kinetic energy, right? The gravitational potential energy will convert into the kinetic energy. So we can say that the GP at the top is equals to the kinetic energy at the bottom, right? So we can write GP is equals to kinetic energy. We can write mass into gravity into height is equals to half mv squared. Now as mass into gravity into height is equals to half mv squared, we can remove this 2 mass and we can write gh is equals to v square, and they have asked us to figure out the velocity. So if you make velocity the subject, the equation becomes 2gh, root over 2gh. And if we put root over 2 into 9.81 into the height, which is 0.60, our answer right here will be 3.43 meters. This is gonna be our final answer, meter per second, sorry. Now moving on to the next part, it says kinetic energy is conserved as the ball bounces up the ramp. So when they have said that the kinetic energy is conserved, that means the kinetic energy before the collision is equals to kinetic energy after the collision. So 3.43 meter per second was the velocity immediately before bouncing. So after bouncing, the velocity is gonna be the same because the mass of the ball is the same. So basically, as the mass of the ball is the same, so it will have the same velocity as well. So here we can say after bouncing, its velocity is 3.43 ms minus 1. And as it is at an angle, we can break it down into two components. One is the horizontal component and the other one is the vertical component. And we know as the angle is with the vertical component will be 3.43 cos 70 because it is with the angle, and without angle it is 3.43 sin 70. Moving on to the next part, it says point A is 0.86 meter vertically above the ground and 1.23 meter horizontally from the end of the ramp. So at the end of the ramp, from it was released or from the position from which it will bounce is 1.23 meter. The question is deduce whether the ball will bounce a second time on the ramp. So it will only bounce second time on the ramp if it has a horizontal distance of less than 1.23 meter, right? So it will bounce right here or here or here, somewhere right here. Or if it has a horizontal displacement of greater than 1.23 meter, it will not bounce on the ramp, right? It will fall right here or here. So this is the main thing. So we will have to figure out the horizontal distance. So we know the horizontal velocity actually, right? We know the horizontal component of the velocity. And we know, as we have seen this formula a millions of times before as well while solving these projectile motions questions, that speed is equals to distance divided by time. This is the formula through which it can be figured out. We know the horizontal speed, we have to figure out the distance, so we just need the time to figure out the horizontal distance. So the time can be figured out using the vertical motion. So let's take vertical motion, and in vertical motion we can use s is equals to ut plus half at squared. And now as the ball will be going up and then coming down after bouncing, right, the ball will go up like this and then come down. So it will have double motion, right? After bouncing, the ball will go up and then come down. So it will have double motion, and we know in double motion the displacement is negative. So it is going to be minus 0.86 Our initial velocity is the velocity here, which was 3.43 sine 70 into t plus half into acceleration is going to be negative as well because it is double motion into t squared. Now if you make t the subject, I'm not going to do all the rough workings because it's your part to do as you guys have grown up. Now t will be equals to 0.555 seconds. Now we have got our time. We can put this time right here and multiply it with the speed, which was, sorry, my bad, we have made a mistake actually right here, which was I have written it sine 70 right here. It will be cos 70. Why it will be cos 70? Because we are talking about the vertical motion, and in the vertical motion you will have to take the initial vertical velocity, which was cos 70. Sorry, my bad. So basically the time is the same, the answer is correct, but I have written cos rather than sine. So it will be t is equals to 0.555 second. Now here you will, what we'll do is we will multiply 0.555 seconds into the speed, which was 3.43 sine 70 to get the displacement. Okay, this is how we will do it. Hopefully you guys can figure the displacement right here, and the displacement will be 1.79 meters. So we have got our answer correct. So this is basically how the projectile motion questions are. So make sure you are revising each and every one of them before your exam day. Alright, so first let's go through this very common but sometimes quite tricky question. The diagram below shows the velocity of an object before and after a force is applied. So basically before, this is how the velocity was looking, which was completely vertical, and after, let's say maybe the force was applied in this direction and now the velocity is in this direction. So the direction of the velocity has changed after the force was applied, but the magnitude of the velocity didn't change. It was absolutely the same. The question says which of the following arrows represents the direction of the change in velocity. Now here basically we will have to be able to draw a vector diagram to answer this question. Now vector diagram is one of the most important part of your Edexcel A-Levels Physics Unit 1 syllabus. If you guys have any issues in terms of drawing vector diagram, you guys can watch my vector diagram video where I have shown everything. I will put the video in the description box. You can check it right there. Now let's draw for this one. Here the velocity was like this before, right? This was velocity like before, and after the force was applied, it became like this. It became like this. It has turned towards right. And the question says which of the following arrows represents the direction of the change in velocity. So basically they're asking about the change in velocity's direction. Now let's draw. It will be like this. So basically this was the velocity before, and this one is the velocity after, which is actually the resultant velocity, and this was the change in the direction. By looking at the arrows you can see it was like this. It was moving in this direction and then coming in this direction, and then it was our resultant. So basically our correct answer will be answer B, because B is exactly the same way our change in direction looks like. Hopefully you guys have understood it completely. Alright guys, I hope you have been finding the explanations helpful so far. And if you want to solve more question papers with me, or if you want to solve this whole unit 1 FAQ with me, then you can join my question papers marathon course, which is designed for the May 2025 students. Though your exam of unit 1 physics is within 2 or 3 days, but still doing 2 or 3 sessions with me will at least help you to score 5 or 10 marks more than what you will be scoring. So without wasting any more time, you can join my question papers marathon course for physics unit 1. And for physics unit 2, 3, 4, 5, 6, you have a couple of more days left, so you can prepare in a much better fashion with me. Now let's talk about the other subjects. We have also the same courses for chemistry, biology, maths, and business subjects. You can join our question papers marathon course to ameliorate your preparation in the last couple of days to score at least 10 to 15 more marks using our exclusive resources and extended hours of classes. We will take classes for 3 to 4 hours to maximize and to boost your preparation. And let's talk about the high impact crash course right now, which is our second course, which is intended for any upcoming sessions. We have these two question papers marathon course and high impact crash course for any upcoming sessions, whether you are October 25 candidate or any upcoming sessions. Whenever you are watching the video, just know that we have these two courses for every upcoming sessions. You can join our question papers marathon course and high impact crash course. Now let's talk about the high impact crash course in general. In this high impact crash course, what you guys will get is you guys will get the chance to complete the full syllabus with me and then do all the recent question papers from Jan 2020 to Jan 25 or the paper before your exam session. So without wasting any more time, join us, and the resources and our exam essentials exclusive notes will be free for you as well as the mocks. To know more about our courses, go through the description box and read the description box given below, or you can message us at our Facebook page, Exam Essentials, or in the WhatsApp number given in the description box. Have a good day, guys. Now let's continue the video and solve few more questions. The question number 16 is a very repetitive question. The question says a steel object is held by an electromagnet. The magnetic force prevents the steel object falling. Okay, so there is an electromagnet which is in contact with the steel object, and then there is an electromagnetic force acting on the steel object from the electromagnet which is resisting the steel object from falling. Alright, now it says state two reasons why the weight of the object and the force from the electromagnet are not a Newton's third law pair. We know for something to be a Newton's third law pair force, the two forces need to be of the same type, right? Now here the two forces that are acting, one is the weight and the other one is the electromagnetic force. So basically both the forces are of different types, so it cannot be a Newton's third law pair. Now it has said to state two reasons. The another reason will be both the forces are acting on the same body, right? The weight is acting on the steel object, and also the electromagnetic force is also acting on the steel object. So basically the two forces are acting on the same body. Both the forces are acting on the steel object. But to be a Newton's third law pair forces, the Newton's third law pair, the forces need to act on the different bodies. Now we can write the reasons. The forces are acting on the same body and they are not of the same type. This is a very repetitive question. Make sure to understand the difference between Newton third law pair force and Newton first law pair force. Now the next question says the electromagnet is suspended from a support by a steel cable as shown. Basically there is a steel cable which is suspended from a support, and then it is connected with an electromagnet, and the electromagnet is connected with a steel object. So because of the electromagnet and electromagnetism, the steel object is in contact with the electromagnet. When the object is suspended, the strain in the cable is this. They have given us the strain. They have asked us to figure out the Young modulus of the steel. They have given us the cross-sectional area. They have given us unstretched length. That means the actual length of the cable before it was stretched, and the stiffness has been given. So as they have given us the strain, we know the formula of strain is del x by L. Right? We know the formula of strain is del x by L. Now we have to we know the original length of the cable, and we know the strain as well, so we can multiply both of them to figure out the del x. So del x is going to be 3.8 into 3.4, sorry, 3 into 10 to the power minus 4, which is going to be 1.14 into 10 to the power minus 3 meters. Now the next part will be to figure out the Young modulus. We need the stress, right? We need the stress. So the formula of stress is force per unit area, and they have given us the cross-sectional area. So we have to figure out the force. So force is equals to K into del X, right? And we know the formula of K is 2.8 into 10 to the power 7 into del X is 1.14 into 10 to the power minus 3, something that we have figured out. So our force is going to be 3.19 into 10 to the power 4 Newton. Now we have our force, we have our del X, we have our strain. We can easily figure out the Young modulus. We know the formula of Young modulus is stress by strain, and for we have the force 3.19 into 10 to the power 4 divided by the area, which is 5.1 into 10 to the power minus 4. So it is going to be, it's difficult to write it like here. We can take it a little. So this is going to be 5.1 into 10 to the power minus 4. So force divided by area divided by the strain, and the strain was 3 into 10 to the power minus 4 given in the question. So basically our Young modulus is going to be 2.1 into 10 to the power 11 Pascal. So basically this is the formula of, this is the answer of Young modulus. Now let's move forward to the most important question, which is this one. It was one of the most difficult question from that October 2023 paper, and a lot of students faced issues in this one. It says the force extension graph for the steel cable is shown below. So it is the total weight of electromagnet and the steel object. So this is the force section graph of the steel cable. So the steel cable is something which is holding the weight of the electromagnet as well as the steel object, right? The weight of the electromagnet and the steel object is on the steel cable. So this is the total weight of electromagnet and steel object, and as weight is a force, so it is indicating this one. And this is the extension, right? This is the extension at that time. When the total weight of the electromagnet and the steel object was there, this was our extension at that point. Now the question says, when the electromagnet is switched off and the steel object falls, right? It is quite obvious that when it will be switched off, the electromagnetism of the electromagnetic force will be vanished and the object will fall. Now student states that the change in elastic strain energy stored in the cable will be transferred to the GPE of the electromagnet. Discuss whether the student's statement you should add on the force extension graph as part of your discussion. So we will have to work on this force extension graph. Always look after this type of things in the question, which is very important. They give us the indications on which you have to actually answer the question, or how you have to answer the question. Now we have to work on the force extension graph first. They have given us the total weight of electromagnet and steel object, and they have also said that the electromagnet is switched off. At that time the steel object falls, and when the steel object will fall, at that time the force acting on the steel cable will decrease, right? When the steel object will fall, the force acting on the steel cable will decrease, right? When the steel object will fall, the force acting on the steel cable will decrease. Let's draw it again right here. If this is the support, now this is going to be like this. Now as when they switched off, the steel object fell, right? The steel object fell. So now this is going to be at a greater height, right? This is going to be at a greater height. Why? Now this was right here, and now this is over here. So basically there is a difference between the height, right? When the steel object fell, the elastic strain energy in the steel cable decreased. Why? Because when there was a steel object right here, at that time the forces acting on the steel cable was the weight of the electromagnet plus the weight of this steel object. But when the switch was turned off, at that time the steel object fell, and the only force that was acting on this steel cable was the electromagnet. That's why the uh, strain energy here decreased and the extension decreased. This is the del x, right? This is the del x. It went up. So as it went up, it gained a energy as well. Sorry, it gained a height as well, right? So when it gained a height, we can say that its GP increased. And where did this GP come from? This GP come from the elastic strain energy, because here when it was stretched, just because of the weight of the both the electromagnet and the steel object, at that time it had a greater extension. This steel cable had a greater extension, and when it has a greater extension, it has greater elastic strain energy acting on it. But now right here, when the steel object has fallen, at that time there is only the weight of the electromagnet. That's why the stretching of the steel cable has decreased. Okay, the steel cable is now less stretched. We can also say the elastic strain energy acting on this um, steel cable is less. Now where did this greater elastic strain energy is turned into a lesser elastic strain energy, right? It was before, let's say, 50 joule. Now it has become 30 joule. So where did that extra 20 joule has gone? That extra 20 joule has been converted into gravitational potential energy. Just because of that, it has gone up and it has gained some gravitational potential energy. So this is basically the concept. And now as there is a difference between the height of this electromagnet was way lower and now this electromagnet is way higher. This is our del x. Okay, this is our del x just because of lesser amount of force acting on the steel cable. So this is the main concept. So basically here, total weight of electromagnet and steel object, we know the extension will decrease, right? This is a greater extension. This extension is for the total weight of the electromagnet and the steel object. But when we will consider only the weight of the electromagnet, at that time the extension will be small, right? Let's say, let's look at this right here. It had this much extension. It had this much extension when it had both electromagnet and steel object. But now it has a smaller extension. Why? Because it has only the weight of the electromagnet right now, no more the weight of the steel object. So we can say the extension will decrease. Now let's draw the extension right here. We can say that this is now the new extension. Okay, this is now the new extension, and this is the force. We can say this is going to be our weight. We can only write the weight of the object. Okay, this is only the weight of the object. Sorry, not the object, my bad. This is the weight of the electromagnet, because the object has fallen when the electromagnet was switched off. Okay, so now it is the weight of the electromagnet. Now we can break it down like this. Now if we think if we think about the gravitational potential energy right now. Okay, let's think of the gravitational potential energy right now. Now if we think about the gravitational potential energy, okay, if we think about the gravitational potential energy, before that we can write down some few more things as well, which is we know the elastic strain energy, right? The formula of elastic strain energy. The formula of elastic strain energy is equals to half into F into del x. And we know here half into this force is the force of both the weight of the electromagnet and the steel of object. So we can write um, we can write weight of the electromagnet plus the weight of the object into del x, right? And while writing the GPE, we can write GP is equals to mass into gravity into height. And now here, this mass into gravity is going to be the weight of the electromagnet solely, right? So we can write weight of the electromagnet into del x, right? The weight of the electromagnet into del x. So now what we can see right here is elastic strain energy is greater than the GP, right? The elastic strain energy is greater than the GP. Why the elastic strain energy is greater than the GP? Because it includes both the weight of the electromagnet plus the object. But here it is only the weight of the electromagnet. So we can say the elastic strain energy is greater than the gravitational potential energy. Now, as we have written all of these things, we can say that this is our del x, right? This is our del x. And we know our GPE was weight into the height. It was, sorry, it was weight of the electromagnet into the del x. So this was our weight of the electromagnet. Weight of the electromagnet is this one, right? The y-axis into this del x. So we can write this del x is this part. This is the del x and this is the weight of the electromagnet. So this is a rectangle, right? This is the rectangle. So basically this is going to be our GPE. And our elastic strain energy is going to be both the weight of the electromagnet plus the weight of the electromagnet and the steel object. So basically this whole graph is going to be my elastic strain energy. So this graph includes the weight of the electromagnet here once and here once. So here it is adding the weight of the electromagnet twice. That's why we will add a 2 right here. I could have actually written it before, but I didn't write because it would have created confusions in your mind. That's why I've written it right now. Okay, so there will be a 2 right here. Let me write it again. So it will be 2 into weight of the electromagnet plus the weight of the object. Why 2 into weight of the electromagnet? Because this whole graph includes weight of the electromagnet here plus, and right here as well, it includes both the weight of the electromagnet plus the steel object. That's why the steel object is once, but the weight of the electromagnet is twice. That's why we have written it 2 right here. Okay, now this is the whole formula, though this formula is not that important for you guys, but I have made you guys understand these things. Now hopefully you guys have understood this whole part. Now let's write it down in our own way, and we will write it down how the answer should be, because the answer is a 5 marks question and you need to explain it in real detail. So now let's understand it. Now let's write it down. Here I have written it more accurately, that this whole graph includes the area of the triangle plus the rectangle. This area of the triangle plus this triangle includes the change in elastic strain energy when the electromagnet fell, sorry, when the steel object fell and the electromagnet moved up. The change in elastic strain energy is the area of this triangle plus this rectangle, but the area of the rectangle is the change in the gravitational potential energy. It includes only the weight of the electromagnet plus it includes the total weight of the electromagnet plus the steel of the object. So basically This is the main concept. Okay. Now let's write down the answer. How we will write it down? We know the area under the graph is equals to the elastic strain energy. The next thing is, as weight of the electromagnet is still exerted on the cable after the steel object falls, we know after the steel object falls, there is still the weight of the electromagnet is exerted on the cable. The next part says change in elastic strain energy is equals to area under the graph between total weight and the weight of the electromagnet only. So basically the area under the graph between total weight and the weight of the electromagnet means this is the area under the graph of total weight and this is the weight of electromagnet. So area under the graph of between these two means it includes both of this rectangle as well as this small triangle. This small triangle as well as this rectangle. Instead of small triangle plus rectangle. This is what they have meant. The next part says change in GP of electromagnet is equals to weight of electromagnet into change in extension, something that I have said previously, that the weight of electromagnet is this multiplied by the extension, this. So basically the rectangle, we know the rectangle is length into breadth, right? So this is the length and this is the breadth. So the weight of the electromagnet is the y-axis and the extension is the x-axis. So we have multiplied both of this to get the GPE, the change in GPE. And we know this whole area is greater than this smaller rectangle. So we can say the change in elastic strain energy is greater than the change in GPE of the electromagnet. Hopefully you guys have understood it completely. This question was a tricky question and it is important to understand this for your upcoming exam. A length of string is attached between two vertical posts. So this is one post and this is another post. A bar of weight W stands on the middle of the string, causing tension in the string. So they have given tensions in both the sides. The string makes an angle of 80 degree with each post as shown. Which of the following expression is correct? Alright, so let's learn about it. Now there is two tension acting in from two different directions and the tensions are acting at an angle, and when a force is acting at an angle we have to break it down into components, right? So as it is acting at an angle, it will have a horizontal component and a vertical component. So let's draw its horizontal component right here. This is the horizontal component and this is the vertical component. So it has both the horizontal components and the vertical components. Now we know this is going to be 90 degree, and if it is 90 degree and this is 80 degree, this angle is going to be 10 degree, and this tension has a horizontal component as well as both of these will have a vertical component as well. So this is the vertical component, and this vertical component is not only for this one tension, this is for both the tension. So it will be 2t. Okay, it will be 2t because both the tensions are at an angle and both of them have their vertical component in the same direction. So we can say there is 2t on this line. Now let's figure out if this as a whole is 90 degree, then if it is 10 degree, then this is going to be 80 degree, right? And if this is 80 degree, then we can say this was previously 2t, right? Because this line is the summation of the vertical components of both the two tensions acting at an angle, and now it was previously 2t. Now this line is with the angle, right? It is with the angle. So if something is with the angle, we can say it is 2t cos 80, right? And weight is acting in the downward direction, and weight and 2t is 2t cos 80 have the same line of action and acting in opposite directions. So we can say weight is equals to 2t cos 80. And now here if we make t the subject, we will get this. C is our correct answer. The first question says a child's slide has a vertical height of 1.7 meter as shown. A child starts from rest at the top of the slide and move down the slide. So basically there will be a children right here and he will be sliding down this slide. The resistive forces acting on the child can be ignored. So basically there will be no resistive forces acting on the child. Actually it will be acting, but we will have to ignore as the question suggests. Explain why the equations of motion should not be used to determine the maximum speed of the child. So basically why we cannot use the equations of motions. Let's say why you cannot use super equations right here. You should consider the shape of the slide. So basically they have given us a hint that why the equations of motions cannot be used, and the reason behind why it cannot be used should be answered in terms of the shape of the slide. So basically there is something about this shape of the slide which isn't allowing us to um, figure out the maximum speed of the child, okay, the maximum speed of the child using the equations of motion. Now one thing you guys can understand is that here the slide isn't completely linear, right? The direction or the shape of the slide is not constant, or it's not completely linear. The shape is just like this. The shape is just like this. So when someone will be going through this shape and someone will be sliding through this gradient, okay, this gradient, his acceleration is not going to be constant. His acceleration will be varying. Why varying? Because the gradient is not constant. If the gradient was completely linear like this and it was constant, then he would have fallen through this place or through this slider with a constant acceleration. At that time we could have used the equations of motion, but here his acceleration will vary. Let's say here he will accelerate with a very high magnitude, but here while reaching this his acceleration will decrease, and in this position again his acceleration will increase. So basically his acceleration isn't constant throughout the motion, his acceleration is changing, and we know in order to use equations of motion our acceleration needs to be constant, right? So this is basically how we will actually write the answer. Now let's go through the marking points, how they have actually written it. If you go through it, they have written the gradient of the slide varies, just like they said that the slide's gradient isn't constant. So the acceleration of the child varies, and the equations of motion should not be applied as they are not only true for constant acceleration. So basically that's the reason. Hopefully this is a 3 marks answer and you guys will memorize these 3 points, because it will be very important to memorize these 3 points. Not only memorize, you guys will have to understand it. Now let's move forward to the next part of this question. The next part of the question says two slides X and Y has the same height. Slide X is longer than slide Y. So basically this slide is a bit longer than the slide Y. All right. They have the same height. This is very important concept. Okay. They have the same height, but as its gradient is not constant and it is in a zigzag line, you can say, so it's not constant, but here the gradient is more or less constant. It is lesser zigzag, it contains lesser zigzag lines than that. That's why it has a smaller, it is smaller compared to this slide X. Now they have the same height, they are released from the same height, this height is the same. This is a very important information that they have provided us with. Now a child moves from rest down at slide X and reaches a maximum speed. So basically when the child was moving through this slide, he has reached his maximum speed, which is Vx. The same happened to the second child who has moved from slide Y and he reached a maximum velocity of Vy. The child on slide Y has a greater mass than on the child on slide X. The resistive forces acting on both children can be ignored. Explain how Vx compares with Vy. So basically they have given us here a contrasting point, which is the child Y has a greater mass. Now you guys might think that if someone has a greater mass, he will be falling through this slide more quickly, right? This is something that I used to believe as well, but this is not gonna be happening right here in this scenario. Why? So basically we will tell about that why isn't it occurring, or why it will occur if it is occurring. This is what they have asked. Explain how Vx compares with V5. Actually, despite it has having a greater mass, how it will behave actually, whether the velocity of Vy will be greater than Vx or what? This is what they have asked us to explain. Now let's think about it in a much more physics way. Now let's think about it. We know both of them have the same height, right? Both of them have the same height. As both of them have the same height, upon releasing, at this point they will be released, right? They will be having their gravitational potential energy, right? They will be having their gravitational potential energy, and upon sliding down the slider right here in this position, they will have a kinetic energy, right? Their gravitational energy will be converting into the kinetic energy, right? While they are sliding at that time also it will be converted into kinetic energy, but right here they will have their kinetic energy. The same is happening for this position. Here they will have their GPE, and right here it will be their kinetic energy, let's say. And while they are sliding they have a velocity, just because of that gravitational potential energy is converting into kinetic energy. Right here they will have a velocity, right? This is the main concept. Now we know this GPE at the top is equals to the kinetic energy at the bottom, right? Because they haven't lost any, there isn't resistive forces acting on it. So we can say GPE at the top is equals to kinetic energy at the bottom for both of them, right? For both of them it is the same. So we can say let's write it down like this. We can say GP is equals to kinetic energy, and we know mass into gravity into height is equals to half mv squared, and both of the sides have the same mass, so we can release the mass because the mass doesn't change upon sliding down the slider, right? So basically we can say GH is equals to half v squared, and if you make v the subject it becomes root over 2gh. So basically your velocity is dependent upon the height from which you are released, and the gravity, as the gravity is constant, it solely depends upon the height. So basically as both of them are released from the same height, they will have the same maximum velocity that they will reach. Their maximum velocity that they will be reaching will be the same as they have been released from the same height, despite one having a greater mass, because the mass gets cancelled out. This is the main reason. So basically hopefully you guys have understood it completely. Now please go through the way I have actually written the answer, and if you have any question you guys can ask me in the comment box if you guys have understand. So basically this is what they have written, Vx is equals to Vy. This is because y, this is the main reason. Hopefully you guys have understood it completely. Now let's move forward to the next question. A student determined the Young modulus of a material in the form of a wire. So basically the material is in the form of a wire, and the student is trying to determine the Young modulus of that particular material which is in the form of a wire. The student used a micrometer to measure the diameter of the wire. So basically he is measuring the diameter of the wire using, let's say, using a micrometer, which is a micrometer screw gauge. Describe how the student should check that the wire is uniform. So to measure if the wire is uniform, let's say let's draw a wire first. We know that wires are in the form of cylinder. We can draw a wire in the form of cylinder. Now in order to figure out whether the wire is completely uniform, we can measure the diameter at different orientations. We will measure the diameter at this position, and then we can measure the diameter at this position. We can measure diameter at this position. Let's say if the wire is completely, if all the diameters value is the same, then we can say yes, the wire is completely uniform. So measuring the diameter at different places is what we can do, right? Now the next question says, check that the wire has a circular cross section. So basically whether this cross section is circular or not, this is what they have asked. So to ensure that it is completely circular, we can measure the diameter at several orientations. We can measure it like this. Let me show you guys how to draw it. We can measure the diameter at several orientations. Let's say we can measure it like this, and then we can also measure the diameter in diameter, actually the circular position, it's not diameter actually. We can measure the diameter of this circle like this. If it is completely circular, though my drawing doesn't suggest that it is completely circular, actually it will be like this. Okay, it will be actually like this. Now if this Now if this circular cross section is completely circular, then it will have the same diameter from every orientation that we will be measuring, right? From, let's say, from here, here, or from here, it will give the same diameter value, right? So that's how we will be make sure that whether the circular section is completely circular or not. Okay, we will check that the wire is a circular cross section. If it is a circular cross section, we know in a circle, no matter from which orientations you measure, you get the same diameter value. And to get the uniform value, we will measure it from this position, whether it has a uniform position of, let's say, if this diameter is 5 and this diameter is 4.5, then we can say it is not uniform, right? All the diameters throughout the wire should be having the same magnitude. This is what it will be. So this is how you'll be writing. To ensure that the wire is uniform, measure the diameter at several positions along the wire. One is along the wire and the other one is several orientations, which is for the circle. Okay, now let's read the next word. The student hung a reference wire. This is the reference wire being tested from the ceiling. At the lower end of the reference wire, he positioned the fixed part of a vernier scale. So this is a vernier scale. The student attached a 100-gram mass hanger to the wire being tested. The initial reading on the vernier scale was 0.0 as shown. He added measures to the mass hanger and measured the corresponding extension of the wire using the vernier scale. So basically he was consistently increasing the mass and then checking how the extension increases in comparison with the mass. So the next question says, the student kept his feet away from the apparatus so that the masses could not fall on his feet. So basically that was a safety precaution he has taken. Now the question asks us to explain another safety precaution that we can give. Okay, now one thing we can see right here, that this is a wire, right? And if you're adding masses over masses in this wire can snap, right? This wire can snap and hit the eyes of the student, right? So the student can wear safety goggles so that if the wire snaps, it doesn't hit his eyes and injures his eyes, right? This is one thing that he can do. So basically this is what I have written. Safety goggles should be worn as the wire may snap and break and hit the eyes. Now the next part says, each time the student added more mass, x increased by a few millimeters. The extension will definitely increase. It's completely normal. Explain why he should measure del x using a vernier scale instead of meter rule. The first thing that comes to my mind reading this answer is everyone every time uses vernier scale rather than a meter rule because vernier scale has a higher resolution. And when something has a higher resolution, its percentage uncertainty is smaller, right? It has a smaller percentage uncertainty. The vernier scale has a resolution of 0.1 millimeter, whereas a meter rule has a resolution of 1 millimeter. So it has a higher resolution. The smaller the value, the higher the resolution. Remember this thing. People gets confused regarding this, that it has a smaller value, but how does it has a higher resolution? Higher resolution means smaller value. Higher resolution means the smaller value that particular vernier scale or a meter rule can measure, or that particular instrument can measure. So basically our vernier scale has a higher resolution than meter rule. So we know the formula percentage uncertainty is equals to uncertainty divided by average measured value. Now as its resolution is smaller, we can say its uncertainty will be smaller as well. As its uncertainty is smaller, we can say its percentage uncertainty is gonna be smaller as well. So that's why we will always choose vernier scale over a meter rule in order to carry out our measurements. So this is the main reason that I have explained in detail. Which of the following could be used to describe the elastic limit of a material? So the question is talking about the elastic limit. It is talking about the elastic limit. So our answer should be specifically regarding the elastic limit, nothing else. Here you guys can see our answer is part B. Why our answer is part B and not A, C, D? Let's go through the question. Choice D. It says the stress at which the material breaks. So they are talking about the braking stress. They are not talking about the elastic limit. It's true. The writing is true, but it's not about the way they have asked us. They have asked about the elastic limit, but it's talking about the braking stress. The part says is the stress at which the material undergoes a sudden increase in extension. We know this is talking about the yield point, right? This is talking about the yield point. Now the part A says the stress above which the material will not obey Hooke's law. This is talking about the limit of proportionality, right? We know the formula F is equals to K into del X. This is talking about that formula and that limit of proportionality. But whereas the answer is about the elastic limit, the limit above which if the stress is removed, still it will be deformed, right? The stress above which the material will be deformed when the stress is removed. So basically this is our answer. So basically from this MCQ, one thing we can understand is you have to be very specific in terms of answering the questions rather than looking at the question and saying that all of them are correct, but it is not the thing that they're asking in the question. So make sure you are giving a little bit of more time while solving the MCQ questions. Now the question number 4 says a ball falls through air from rest. So basically he is falling through the air. So there he is in free fall, right? In free fall we know it is accelerating, right? In free fall, a ball or a human, when he is in free fall, he accelerates, right? Someone accelerates when he is falling through the air. And acceleration means increase in velocity. It doesn't mean increase in velocity, it means change in velocity, but as he is falling, so there will be an increase in the velocity, right? And now here you guys can see all the 4 graphs that they have given is all of them are displacement time, and we know the gradient of displacement time graph gives us our velocity. And in the first graph it's a straight line where the velocity is not changing because the gradient is 0 right here, so we cannot take this one. The next one says this is a constant graph, right? This is a constant gradient, and we know our gradient needs to be increasing. The D is the gradient is decreasing, and we know our graph cannot be decreasing gradient. Our velocity will be increasing. So basically that's why our correct answer is C. Now the next question says a helicopter moves vertically upwards with an increasing speed. So basically the speed of the helicopter is increasing. This is very important thing to remember. The speed of the helicopter is increasing. Which of the following describes the increase in gravitational potential energy of the helicopter? So basically our points should be mentioning about the increasing GPE, nothing else. It should be mentioning about the GPE, right? And we know GPE is only about the formula suggests mass into gravity into height. So basically when someone has a gravity y because he has done work against the force of gravity, right? Someone has gravitational potential energy. Let's say you are in the 5th floor of an apartment, you have a gravitational potential energy. Why? Because while climbing into the 5th floor you have done work against the force of gravity which is pulling you downward, right? So that's why the formula suggests that mass into gravity to height. You have achieved the height, and in order to achieve the height, actually your mass has achieved the height. Why your mass has achieved the height? Because you have done work against the force of gravity. Now let's go through the points that they've given. The work done on the helicopter by the force of gravity. We are talking about your mass doing the work against the gravity, not the gravity doing work on you. So basically this is not the answer. The total work done by the helicopter as it moves upwards. This is a very confusing part because it says work done by the helicopter, and we know the helicopter when it was moving up it was doing work, right? But just this one total word is the reason why we cannot pick this one as our answer, because it says the total work done, and while moving up it wasn't only doing, or it wasn't only gaining the kinetic potential, it was not only gaining the gravitational potential energy, it was also gaining the kinetic energy as well because its speed was increasing. So the total work done was both the kinetic energy and the GPE. So that's why the question was saying about the GPE only, so we cannot take this one. Now the fourth point, which wasn't the correct answer as well, the work done by the helicopter to increase speed, and we know increase speed is about the kinetic energy. But the question says only about the gravitational potential energy, though he has said something about increasing speed before, but this question only refers to the GPE. And C is the correct answer because it says the work done by the helicopter against the force of gravity. And this is what the answer is, and the formula suggests, as I have said at the start while solving this one. Hopefully you guys have understood this one as well. Now let's move forward to the next question. A student carried out an experiment using a data logger to record the motion of a ball bearing as it fell through a liquid. Student state the conditions under which Stokes' law applies to an object moving through a fluid. We know for Stokes' law to be applied, this is a very common question. The conditions for Stokes' law, we know the ball needs to be spherical and the ball needs to be small so that it flows with laminar flow. Small spherical objects moving at low speeds with laminar flow, and it has to be spherical as well. It has to be small as well. These are very important things. And it has to move at low speeds with laminar flow. So these four things are very important. Memorize this one because this is a very common question. Now the next part says the student heated the liquid and repeated the experiment. The ball bearing took less time to fall at a given distance in the liquid when the liquid was at a higher temperature. Explain why. Assume the density of the liquid is constant. Okay. And it also means that the upthrust is also constant. Though this is not written in your question paper, but this is something that I have written for you guys to understand easily. So basically, when there is a high temperature, we know the viscosity decreases, right? At high temperature, the viscosity decreases. And as the density is constant, the upthrust is constant as well. Now let's go through the formula of drag. We know drag is equals to 6 pi r eta v, right? And when the viscosity decreases, as the viscosity has decreased, as viscosity and the drag force is directly proportional, the drag force should decrease as well, right? But the drag force here cannot decrease. Why? Because when a ball is falling down, we know weight is equals to upthrust plus drag, right? And here they have said that the density of the liquid is constant. And when the density of the liquid is constant, this upthrust is also constant. And if the upthrust is constant, then we know weight is also constant. And if these two values are constant, this drag needs to be constant as well. It has to be constant as well, because if the drag decreases, then weight plus drag will not be equal to the upthrust, right? The weight plus drag will not be equal to the weight. The weight plus drag will not be equal to the weight, and they have to be equal, right? So that's why the drag will be constant as well. Now the question arises, if the drag has to be constant, then if the viscosity decreases, something must change right here. The thing that will be changing right here is the terminal velocity will increase. The terminal velocity will increase to compensate the decrease in the viscosity so that the drag remains the constant. And now if the terminal velocity is increasing, we know according to speed is equals to distance divided by time taken. If the speed increases, the time taken to reach the destination decreases. So the ball bearing will take less time to fall at a given distance. The student was correct. Now the answer says at a higher temperature, the viscosity of the liquid will be lower. Since drag is equals to 6 pi r eta v, where the radius is constant and the drag force or terminal velocity is the same, hence viscosity is lower, the terminal velocity is greater than before, so the ball bearing will take less time to fall the given distance. So this is how you guys will have to explain it. These questions are really tricky, but they are always in the exam papers. They are more or less in every exam paper, so make sure you are understanding it completely and then memorizing it, because the mark scheme points are really important to memorize, and don't, so that you don't miss any keywords in the exam and lose marks despite understanding the question. All right guys, so now let's go through another fluid mechanics question that we have seen previously. This is exactly the same but in a different way. How to answer it in a different way, how different questions of fluid mechanics actually come. Let's go through it. It says foraminifera, known as forams, are small sea creatures with shells. When forams die, they sink slowly through the seawater to form a layer at the bottom of the sea. The photograph shows a magnified view of some typical forams. And the question says the forams sink deeper into the sea. The temperature of the water becomes lower. Discuss how the terminal velocities of the forams changes as they sink deeper into the sea. Here, something that I can see is the temperature was lower. And we know when the temperature was lower, that means the viscosity was higher. And the forams were going deeper into the sea. That means the density was higher. And we know when the density was increasing, the upthrust will also increase, right? The upthrust will also increase. And we know as the forams are going down the sea, we know upthrust plus drag is equals to our weight. And as the upthrust has increased, okay, as the upthrust has increased, we know drag is equals to 6 pi r eta v. And as the viscosity is also increased, the drag will also increase. So basically upthrust plus drag both are increasing. So both have increased and now both has increased. As upthrust and drag both are upward force, as the upward force is now greater than the downward force weight, the resultant force will be upward, right? The resultant force will be upward. But as the ball is going down and the resultant force is upward, we know the ball will decelerate, right? The ball will decelerate. Why the ball will decelerate? Because the resultant force is in the opposite direction to the direction of the motion of the ball or the forearms. So that's why it will decelerate. So its terminal velocity will decrease. So this is how we will actually answer this question. It says for liquids, as temperature decreases, the viscosity increases. And we know drag force increases for a given velocity, right? If the velocity is constant, for as the viscosity has increased, the drag force will be greater. And as the depth increases, the density will also increase, so the upthrust will. And as the weight remains constant, the resultant force will be upward. So that means as the resultant force is upward and the ball is going downward, we can say terminal velocity decreases with increasing depth. So this is how we will have to answer this question. Now this was one question, and the other question that we have seen just a couple of minutes back was this one. So these are the same type of questions but needs to be answered in a different approach, because in this question here the upthrust was constant. You guys can see the density was constant, that's why the upthrust was constant. And here the upthrust was increasing. And in this question, okay, they were talking about the ball bearing took less time. This question was about the ball bearing taking less time. That means someone will take less time only if its terminal velocity increases, right? And here they didn't talk anything about less time or greater time. That's why we didn't bring in time right here. But here we bring in resultant force because the upthrust has increased. And here the upthrust was constant. That's why the resultant force was constant in that question. So basically these are the main things that you will have to see. Okay. Both the question was the same type of question but a couple of different. So make sure you're looking at each and every quantities very closely and then answering the questions, because it is extremely important to answer the questions in the perfect possible way. Otherwise you will lose marks here and there, or you might mess up the whole question. This is exactly the same question that we have solved previously, where a VT graph was given, a velocity time graph was given, and positive negative displacement was necessary. Right here you can see a velocity time graph has given, and they have asked to show the following expressions of the total displacement of the particle. Now in this graph, this is the area under the graph, right, of R, which is in the positive direction. That means we know the area under the graph of the velocity time graph gave us displacement. So we can say here the displacement is positive, and here in Q it is in the negative axis of the velocity time graph. We can say here it is negative displacement. So we can say if we have to figure out the total displacement, we will add both of them. We can add, let's say, plus d plus minus d, not actually d. We can write this is r, right? R is positive, plus the q, and the q will be negative. Why? Because the displacement is negative, so we can write minus q. So well, the expression will be r minus q is our total displacement, and the correct answer is D. This is exactly the same way we have done the previous question, right? So Edexcel actually repeats the questions, but you don't understand. The thing that you will have to understand is how to remember the concepts, because the concepts are always the same. Another tricky question. A compressive force is applied to an object made of material with Young modulus E. The original length of the object in the direction of the force is x. This is a very important thing, that the original length is x. Okay. And its cross-sectional area is A, which expression gives the length of the object after the force is applied. So the length of the object after the force is applied means this length includes the L naught plus the del x, right? Because this was the original length and this is the change in the length. So the original length plus the change in the length is the actual length of the object after the force is applied, right? This is the main thing. Now let's discuss this part in detail. Let's take a spring right here. This is the length of the string. This is the length of the spring, which is, let's say, L naught. L naught is the length of the spring. Now they have said a compressive force is applied. That means it will be compressed. Let's compress it right now. If we have compressed it, if we have compressed it, okay, if we have compressed it, we know this is the change in length, right? This is the del x. This is the del x, and this L is our new length. But as we have written that the new length is equals to L naught plus del x, this is for the stretching force, not the compressive force. For the compressive force, the formula will be L is equals to L naught minus del x, right? L is equals to L naught minus del x. So basically the formula, if you have written this one for this question, your answer would have been wrong. So make sure you're looking at it and figuring out that it is a compressive force. Now we know L is equals to L naught minus del x. Now they have asked us that Young modulus. Now let's write the formula of Young modulus. We know Young modulus is equals to force per unit area divided by del x by L, right? Which can be written as force into length, because the value with which you divide the denominator comes and multiplies with the numerator. We can write F into L divided by del x into A, is equals to the Young modulus, and we know, and we can also make this del x the subject. So it becomes del x is equals to L naught minus L, right? Now what we can do is we can make del x the subject right here as well. So it will become F into L divided by area into Young modulus is equals to the del x. And we know that del x is equals to L naught minus L. So we can put it right here. So the equation becomes L naught minus L is equals to F into L divided by area into Young modulus. And we all know that this length is actually the length of the object after the force is applied, right? This is the length of the object after the force is applied. And now we will have to make this L the subject. So if we make this L the subject, it becomes L naught minus FL divided by AE is equals to L, right? And this L is the length of the object after the force is applied, this L. And this was our L naught, which was the original length. And we know this is our original length. And rather than writing this as L, we can also write it down as L naught, because this L is this L, right? So this was del x by L, which means change in length divided by original length. So it can be written as L naught as well. So we can write this down as L naught, right? This is also our L naught, or the original length. And they have written that the original length of the object in the direction of the force is x. So rather than writing both of them as L naught, we can write them down as x. So we can write L is equals to x minus fx divided by a into Young modulus. This both of these are our L naught, and we know our L naught is the original length, and they have written the original length, they have denoted the original length as x. So that's why our formula is L is equals to x minus fx by the a into Young modulus. So our correct answer is D. This was a very tricky question. Hopefully you guys have understood it completely. Alright guys, so now let's solve another very important multiple choice question. This was very confusing that even few teachers have written it wrong. Okay, so let's study this. It says a van travels along a straight horizontal road at a constant velocity. So when something has a constant velocity, its resultant force is zero, right? Its resultant force is zero. Now it says which of the following statement is correct. Now here our correct answer will be answer C. Many of you guys would have written that the correct answer is D, but no, correct answer is not D, because as the resultant force is zero, the answer should have been that the frictional force of the road is in the opposite direction to the motion of the van, right? This should have been the correct answer, but no, this is actually not what is happening. Okay, this is not actually what is happening. Now let me understand this answer in detail. Now the way we will actually explain it is, when the car is moving forward, at that time, the car is giving a backward force to the ground, right? The car is giving a backward force to the ground, and according to Newton's third law, the ground will also give a forward force to the car. So the ground is giving a forward frictional force to the car forward. So the car is moving forward, and the frictional force given by the ground, listen to me carefully. So the car is moving forward, and the frictional force given by the ground to the car was also forward. So this is what the answer C says. The frictional force of the road on the tire or the car is in the direction of motion of the van. This is what the answer was looking for. Now why will actually omit the question A? Because it says the frictional force of the road on the tire can be ignored. No, this is not the same. This is not the thing. You have to take that thing into account. The frictional force of the road on the tire is equal to the resultant force on the van. No, this is absolutely bullshit. But why the D is incorrect? Because the resultant force is never ever equal to the friction. Because the resultant force itself is connected to the frictional force. Now in part D it says the frictional force of the road on the tire is in the opposite direction to the motion of the van. No, it is not in the opposite direction. The force that was in the opposite direction was the force that the car gave to the ground, was this force, right? This was the force that the car gave to the ground, which was in the opposite direction, and the frictional force given by the ground to the car was in the forward direction, and the car was also moving in the forward direction. So we can say our correct answer is C. The frictional force of the road on the tire is in the direction of motion of the van. I have written explanation right here. It says when a van travels at a constant velocity along a straight horizontal road, the net force on it is zero, meaning all the forces are balanced. Although friction is often associated with opposing motion, in this case the static frictional force acts forward in the direction of the man's motion. How? This is because the tires are rotating and trying to push the road backward, right? The tire is pushing the road backward. Due to the torque from the engine, in response, according to Newton's third law, the road pushes the tire forward through static friction. It pushes the road forward. This forward force is what allows the tire to grip the road and move the fan forward. Without this friction, the tire would spin in place. We have seen this thing in National Geography, right? In a very when it rains, and sometimes when the road is very slippery, the tire keeps on rotating. The tires keeps on rotating. The tires keeps on rotating, but the car doesn't go forward. Why? Because there is no frictional force from the ground to the car to make the car move forward. So it is the frictional force from the road in the forward direction that enables the van to actually accelerate or maintain motion. Otherwise, no matter how fast the tires spun, the vehicles wouldn't go anywhere. So that is how. Then the correct answer is C, and it was a very tricky question, so make sure you are understanding. Now you guys might still have a question that I have said that the net force is 0. That means the resultant force right here is 0. So if the resultant force is 0, then what is actually happening right here? We know the car is moving forward, right? The car is moving forward. So we know that forward force is equals to the resistive forces. So which are the resistive forces right here? The resistive forces can be air resistance, which is acting on the opposite direction, and there is also a rolling force. As the car is rolling, there is also a rolling force which is acting to the opposite direction, to the direction of motion. And the forward force is this forward force plus the static frictional force. This two is acting in the same direction, and the resistive force, air resistance, plus the rolling force, these two force and these two force are equal, and this is how the resultant force is 0. If we make these two force subtract this force, the resistive force of um, air resistance is acting as a resistive force right here, and the rolling force, you don't need to know about the rolling force because this is not in your syllabus, but yeah, the rolling force and the resistive force, air resistance, is acting in the opposite direction of the driving force and the static frictional force, and as both of these forces are equal, we can say that the resultant force is 0. And there might still be a question going through your mind that as it is moving at a constant velocity, the resultant force should have been 0, right? Yes, the resultant force is still 0. So how is the resultant force 0? The resultant force is 0 because let's talk about the forces that is acting to the right. This is the driving force plus the frictional force. No, actually, yes, the frictional force. So we can say the frictional force and the driving force is acting towards the right, and the force that is acting in the opposite direction to the direction of motion is the resistive force, and the resistive force right here is the air resistance plus the rolling force. You guys don't know actually the rolling force because this is not in your syllabus. The rolling force is because the car is rolling in this direction, right? So there is a force in this direction as well. So the rolling force is this one. So this rolling force plus the air resistance is equal to the driving force plus the static friction from the ground to the tire in the direction of motion of the car. So basically this is how the resultant force is 0. Okay, this is the main concept, and we can say that the driving force and the frictional force is on the same direction of motion, in the direction of motion, as the driving force is in the direction of motion as well as the frictional force. And part B is incorrect. This is why, because the frictional force is not equal to the resultant force, because the resultant force is the subtraction of driving force plus frictional force minus the resistance plus the rolling force. Okay, though you don't need to know about rolling force, but I have still specifically written this to make you guys understand this concept, because this was a very critical concept and confusing as well. Hopefully your confusion has been overturned. The question number 18 says a uniform door of width W is supported by two hinges X and Y. This is the first hinge and this is the second hinge, which is the X and Y hinge. And this W is our width. Okay, this W is our width. X and Y are at a vertical distance L apart as shown. So basically this is the L which is aparting the hinge X and Y. So the question A says state the conditions needed for the door to be in equilibrium. So for the door to be in equilibrium, what are the conditions that is required? For anything to be in equilibrium, the resultant force must be 0. And as it is a moment question, the moment about any point should be 0 as well. Right? There should be no resultant moment. This is a 2 marks question, which is a very common question. So please make sure you have a very good hand on it. Now, the next question says, give the meaning of the term center of gravity. The point at which the weight of an object is considered to act is called the center of gravity. Hopefully, কারো কোনো problem হওয়ার কথা না. But the reason behind picking these A and B questions is because the center of gravity. They have given you a hint regarding the center of gravity on the question number B. Now, it's your turn to figure out where the center of gravity will act. We always know the center of gravity always acts from where the weight of an object acts, which is at the middle. So let's say this is the point from which our weight will act. This is the point from which our weight will act. So this is our center of gravity. Okay, nothing else. Now let's see what the question says. The diagram shows the force acting on the door at each hinge. So X and Y are our hinges. The mass of the door is 14.4 kg, and we know the mass always acts from the center of gravity, and our center of gravity is right here. Our center of gravity is right here. So this is where from which our weight will act. So the mass of the door is given as 14.4 kg. The weight of the door causes a moment about each hinge. So as the weight is acting, it will create a moment from both the hinge X and Y. Show that the horizontal component of the force of hinge Y on the door is about 40 Newton. So one thing that we can see is the force Y is at an angle, right? It is at an angle. So as it is at an angle, we can assign it with horizontal and vertical components. So these are our horizontal and vertical components. These are our horizontal and vertical components. And as X is also a hinge and X is also a force, it will also have a horizontal and vertical component. Now this is the vertical component of X and this is the horizontal component of X. Okay, these are the horizontal and vertical components. One thing that we can say is the vertical components of both X and Y is in the upward position, right? Both of them are in the upward position. So we can say as the two forces are acting in upward direction on the door and only one of the forces acting in downward position on the door. So we can say that these two upward forces will balance out this one downward forces, or what we can say, one downward force will balance out the two upward forces, right? The two upward forces, right? So now this weight will be shared between these two vertical components of the hinge X and Y. So we can say this vertical component will be W by 2 and this vertical component will be W by 2, right? Because the whole weight has been shared by the two upward components of the hinges X and Y, as both the vertical components are in the upward direction and the weight is acting in the downward direction on the door. Now the question they have asked us about the horizontal component of the force of hinge Y. Okay, the horizontal component. We know the vertical component of hinge Y is W by 2. So it's not difficult to figure out the horizontal component now, as we know the vertical component. The first thing that we will have to do is we know the mass of the door. So we will multiply it with 9.81 to get the weight. So weight will be 14.4 into 9.81. This will give us our weight, which is 141 Newton. So we know our vertical component is 141 Newton. Now we just need to figure out our horizontal component. So to figure out the horizontal component, we will have to use moment. We know total clockwise moment is equals to total anti-clockwise moment. Total clockwise moment is equals to total anti-clockwise moment. So here our clockwise moment is going to be our weight. If we take, let's say, for here, what I will do is I will take X as our pivot. Okay, we will take X as our pivot. So if we take X as our pivot, now weight for our clockwise moment, weight, this is going to be our clockwise moment and this is going to be our anti-clockwise moment. So for clockwise moment, the weight is acting downward and we need perpendicular distance. The perpendicular distance is going to be this distance, right? This is going to be our perpendicular distance for the weight, and we know this whole is 0.85. They have given us the width as 0.85 and this length as 1.60. So we know our width is 0.85 and it is at the middle, so it will be 0.85 by 2. So our force is 141 Newton, which is the weight, into 0.85 by 2. Okay, is equals to the total anti-clockwise moment. For total anti-clockwise moment, we will take the horizontal component right here. Okay, we will consider the horizontal component. If we consider the horizontal component of hinge Y, which is acting like this, right? Which is acting like this. This is the force. F horizontal, let's say F horizontal. Now for F horizontal, if we take this force, we have to take the perpendicular distance, and the perpendicular distance will be straight, right? The perpendicular distance will be this distance from the hinge X to the hinge Y, right? This distance, which is going to be our 1.60. So we'll take it down as FH into 1.60. So if we make the horizontal component the subject, FH, our answer will be 37.5 Newton. So this is how it will work. কোনো প্রবলেম আছে মোস্তফা, বলেন তো এই পার্টটাতে মোস্তফা?
ভাই তাহলে আপনি এখানে হচ্ছে দুটো কম্পোনেন্টের একটা কম্পোনেন্ট নিচ্ছেন তাই না, ভার্টিক্যালের এক্স আর ওয়াই কে এক্সট্রা একটা পিভট ধরে নিচ্ছি।
এক্স আমরা পিভট ধরে নিচ্ছি, হ্যাঁ। দুটো কম্পোনেন্ট একটা কম্পোনেন্ট নিছি মানে আরেকবার একটু ক্লিয়ারলি কোশ্চেনটা করেন তো কাইন্ডলি।
মানে এক্স ওয়াই দুইটা হিঞ্জ ছিল না, তো এক্সটাকে পিভট ধরে নিলে তো হচ্ছে ভার্টিক্যাল কম্পোনেন্ট ওয়াই এরটা ইউজ করতেছি, সেটা বলতে।
হ্যাঁ, শুধুমাত্র ভার্টিক্যাল কম্পোনেন্ট ওয়ারটা ইউজ করতেছি। আপনি ফুল এক্স রে তো পিভট হিসেবে ধরছেন, তাহলে এক্স পুরোটাই আমার টোটাল ক্লকওয়াইজ আমার মোমেন্টের ইকুয়েশন থেকে বাদ করে যাবে। আমি খালি এই দুইজনের নিয়ে এখন কাজ করব, এরে নিয়ে আর এরে নিয়ে, ঠিক আছে? ও পুরোপুরি বাদ করে গেছে, ঠিক আছে? আর আমি ওরে ইউজ করছিলাম একটু আগে ডাব্লিউ বাই টি টা বের করতে, বিকজ আমি জানি যে আমার দুইটা আপওয়ার্ড ডাইরেকশনে আছে, দুইটা ভার্টিক্যাল কম্পোনেন্ট আর একটা ডাউনওয়ার্ড ডাইরেকশন, তাহলে এইটা ইজ ইকুয়ালস টু এই দুইটা, রাইট? এটা তো আমরা জানি, রাইট? এরকম কিছু। আবার লেটস সে হিঞ্জের যে আমার হরিজন্টাল কম্পোনেন্ট হচ্ছে আমার রাইটে, আর হিঞ্জ ওয়াই এর কম্পোনেন্ট হচ্ছে রাইট এ লেফটে, সরি ও রাইটে ও লেফটে, তাহলে এই দুজন হচ্ছে আমার সেম টু সেম হবে, বিকজ দুজন দুই ডিরেকশনে আছে, তাই না? এরকম হচ্ছে ব্যাপারটা। এই জিনিসটা কি জানা আছে সবার? আগে প্রবলেমস আছে বলেন তো? একটা ফোর্স যদি এদিকে থাকে আর একটা ফোর্স যদি এদিকে থাকে, দুটো ফোর্স কিন্তু সমান সমান, বিকজ বোথ অফ দেম আর অ্যাক্টিং ইন ডিফারেন্ট ডাইরেকশনস বাট দে আর ইকুয়াল ইন ম্যাগনিটিউড, ঠিক আছে? এই হচ্ছে কাহিনীটা এই কম্পোনেন্টস এর দিক থেকে আর কি। এই পার্টটাতে কি কারো কোনো সমস্যা আছে মোস্তফা, বলেন তো?
Okay, but to বুঝান তো the clockwise moment and the anti-clockwise moment again. Could you explain that again?
আচ্ছা আচ্ছা, ঠিক আছে। এই কোশ্চেনটা কিন্তু আপনারা কেউ দেন নাই, বাট স্টিল আমি এটা পিক করছি কেন? জাস্ট বিকজ আই নো প্রবলেমস থাকবে, এই জন্য। কেন দেন নাই কেউ?
আমি দিয়েছিলাম।
হ্যাঁ আমি দিয়েছিলাম তো।
না, আপনারা দিছিলেন কোনটা? আমি বলি আপনারা দিছিলেন এই যে এটা, এটাও না, আপনারা দিছিলেন এই যে এটা, যেটা এফিকিউতে ছিল, কিন্তু পুরোটা কেউ দেন নাই। মনে হয় না কেউ জেন 24 পেপারই করছেন। আচ্ছা
হ্যাঁ আমি গ্রুপে দিয়েছিলাম কয়েকবার, আপনি কেমনে দিয়েছিলেন?
আচ্ছা, গ্রুপে দিছিলেন আপনি?
আমি গ্রুপে দিয়েছিলাম, আপনাকেও কয়েকবার দিয়েছিলাম।
আচ্ছা আচ্ছা, তাহলে মেবি
আমি দিয়েছিলাম, আমি আপনার পার্সোনাল ডিএমএ দিয়েছিলাম।
আপনি দিয়েছিলেন?
জি।
আচ্ছা আচ্ছা আচ্ছা, ঠিক আছে, তাহলে আমি মেবি খেয়াল করি নাই। যাক, মিলে গেছে। এখন দেখেন, সেন্টার অফ গ্র্যাভিটি যদি মাঝখানে অ্যাক্ট করে, আমার ওয়েট ওই দিকে অ্যাক্ট করবে। এখন একটা কথা হচ্ছে গিয়া যে আমার ওয়েটটা অ্যাক্ট করতেছে ডাউনওয়ার্ড, ঠিক আছে? আচ্ছা, ওয়েট অ্যাক্ট করতেছে ডাউনওয়ার্ড। এখন আমার ফুল ডোরের মধ্যে কি কি ফোর্স অ্যাক্ট করতেছে? আমার ওয়াই এর হিঞ্জ থেকে একটা ফোর্স অ্যাক্ট করতেছে, এক্স এর হিঞ্জ থেকে একটা ফোর্স অ্যাক্ট করতেছে, রাইট? দ্য ফোর্স অ্যাক্টিং ফ্রম দ্য হিঞ্জ এক্স টু, তাহলে আমরা একটু ইয়া করে, যতটা একটা অ্যাঙ্গেল অ্যাক্ট করতেছে, কোন ফোর্স অ্যাঙ্গেল অ্যাক্ট করলে ওরা আমরা কি করি? হরিজন্টাল ভার্টিক্যাল কম্পোনেন্টস দিলাম, হরিজন্টাল ভার্টিক্যাল কম্পোনেন্টস, ঠিক আছে? সেম ওয়াই রেও দিলাম, সেম ওয়াই রেও দিলাম। দেওয়ার পর আমি কি বুঝলাম? দেখতেছি আমি আমার ফুল এখানে তিনটা ফোর্স আমার অ্যাক্ট করতেছে স্ট্রেট লাইনে। একটা হচ্ছে এইটা, একটা হচ্ছে এইটা, একটা হচ্ছে এইটা। তিনটা যেহেতু আমার একদম স্ট্রেট ভার্টিক্যালি অ্যাক্ট করতেছে, তাহলে দুটো উপরে অ্যাক্ট করতেছে, একটা নিচে অ্যাক্ট করতেছে, তাহলে কি বুঝা যেতেছে? পুরোটা তো ইকুইলিব্রিয়ামে আছে। ইকুইলিব্রিয়ামে থাকা মানে কি? আমার ফোর্স ব্যালেন্সড, তাহলে আমার আপওয়ার্ড ফোর্স ইজ ইকুয়ালস টু ডাউনওয়ার্ড ফোর্স থাকার কথা না? ইকুইলিব্রিয়াম যত আছে, ভার্টিক্যাল আপওয়ার্ড ফোর্স ইজ ইকুয়ালস টু ভার্টিক্যাল ডাউনওয়ার্ড ফোর্স এর কথা। তাহলে দুটো ভার্টিক্যাল আপওয়ার্ড ফোর্স এর সামেশন মিলে আমার একটা ভার্টিক্যাল ডাউনওয়ার্ড ফোর্স। তাহলে আমার ফুল ওয়েট যদি এইটা হয়, তাহলে দুজন মিলে হাফ হাফ করে ভাগ করে নিল, ওয়েট ডিভাইড বাই 2, ওয়েট ডিভাইড বাই 2, এই জন্য দিছি, ঠিক আছে? এই গেল আমার কাহিনী। কাহিনী আমার এখানে শেষ। এইবার আপনি বলতে পারেন যে ভাই, আপনি যখন ম্যাথটা করছেন ভাইয়া, আপনি কেন এখানে এটারে পিক করছেন? টোটাল ক্লকওয়াইজ মোমেন্টে আপনি কেন এখানে আমি যে এই যে ওয়েটটারে পিক করছি, আপনি কেন ওয়েটরে পিক করেন? আপনি ওয়েটরে কেন পিভট ধরে ম্যাথটা করলেন না? আমি ওয়েটরে পিভট ধরে ম্যাথটা করুম কেমনে? আমার তো একটা ভ্যালু জানা লাগবে, তাই না? আমি যদি ফুল এক্স এর ভ্যালু জানতাম, ফুল এক্স এর মোমেন্ট কত আমি জানতাম, তাহলে আমি এটা নিয়ে কাজ করতে পারতাম। আমি ওরে ধরে কাজ করে ডাব্লিউ এর এটারে আমি মোমেন্ট ধরতে পারতাম, কিন্তু জানি না। এই জন্য আমি যেটা জানি ওটারে দিয়ে কাজ করতেছি, যে কোনো একটারে আমার এটা আমি জানি, দিস ওয়ান আমি জানি, আমি আমার ওয়েট জানি, ম্যাথ দিয়ে আমি ওয়েট বের করছি। আই ক্যান ফিগার আউট মাই ওয়েট ফ্রম দ্য ম্যাথ, ইউজিং দ্য ম্যাথ। and I will have to figure out this one. So I will have to work with this too, so that I can take a moment on this part. Okay, so this is how you will have to approach the questions. Bolan?
ভাইয়া তাহলে যদি আমরা এক্স এর ভ্যালুটা জানতাম তাহলে তো ক্লকওয়াইজে এক্স এর সাথে পারপেন্ডিকুলার ডিসটেন্স দিতাম।
হ্যাঁ, এক্স এর ভ্যালু তো আপনি জানা লাগবে, এক্স এর হিঞ্জের ফোর্স তো আর আপনি জানেন না কমপ্লিটলি, তাই না?
মানে যদি ওটা বলে দিত তাহলে তো আমরা এক্সটা নিয়ে মানে ওয়াই ডব্লিউ কে পেপার ধরে নিতে পারতাম।
জানি কত, হরাইজন্টাল কম্পোনেন্ট জানি আমি, যেটা আগে বাইর করছিলাম কত জানি, 37.4। আমি কি পাইথাগোরাস দিয়ে বাইর করতে পারবো কি পারবো না? এটা হচ্ছে যদি আমার 37.5 হয়, 5 না 4 জানি ছিল 5, হ্যাঁ। ভার্টিক্যালটা যদি আমার w/2 হয়, মানে w/2 মানে হচ্ছে 141/2, বিকজ আমি w জানি 141, তাই না? তাহলে it's not an issue to figure out this f, right, using the Pythagoras theorem and the angle as well, this angle, right? এটা কি আপনারা বের করতে পারবেন? বলেন, এই অ্যাঙ্গেলটা বের করতে কি কারো কোনো সমস্যা হবে? তাসফিয়া বলেন তো।
না ভাইয়া।
আশা করি এটা বের করাটা is not an issue. I'm explaining once again. আরেকবার explain করতেছি, শুনেন। The thing is, they have asked us in this question about the force and the angle theta. Now, to figure out this force F, this is our vertical component, which was W/2, right? Here we figured out it was W/2. So as it was W/2, we know our W was 141 and divided by 2. And our vertical component was 37.5 that we have figured out. Sorry, the horizontal component was 37.5 that we have figured out. Now we just need to figure out this force F. So if we draw a triangle like this, the horizontal component is 37.5, the vertical component is 141/2. Now you just need to figure out this force F and this theta values for angle theta and force F. You can use Pythagoras theorem to figure this out. So this is not an issue, I think. Pythagoras theorem, if you use the Pythagoras theorem, what will be the answers? Please let me check the answers first. So our theta value will be 28.0 degree and our force will be 80.0 Newton. So these two will be important for the next part. Now the next part, they have said an identical door is supported by hinges that are much closer together. In the identical part, the hinges will be much more closer. Okay, the hinges will be much more closer. So let's take this picture right there. So basically right here, let's take it right here. So basically, let's say these two hinges will be way more closer together. Okay, the hinges will be way more closer rather than this length. When 1.60, the length will be smaller between the two hinges. Explain how a smaller value of L affects F and theta. You should consider moments about point X. Okay, so basically to be able to excel in this question, you have to be very good in terms of solving this question. Now the thing we'll have to do is we'll have to solve it in a much better way. Okay, you will have to solve it in a much better way. Let's say for using Pythagoras theorem, what you can do in this question to figure out force is equals to 80 Newton, what you will have to do is, F is equals to root over 37.5 squared plus 141 divided by 2 squared, right? Which will be 80 Newton. This is how it will come. And for theta, we know tan theta is equals to 37.5 divided by 141/2. So theta will be inverse of this, right? Sorry, not like this, the tan inverse of this value. So basically the reason behind bringing it was our tan theta value was FH/FV, right? FH/FV. This was the tan theta value. Now let's go through these answers. Here, an identical door is supported by hinges that are much closer together. Explain how a smaller value of L affects F and theta. So this L value will be smaller. The L value will be smaller. You should consider moments about point X. So you will have to take moment at X. So if we take pivot at x, our equation was like this. If we took pivot at x, our equation was like this, right? If we take pivot at x, our equation was like this. So basically this was our equation when we took pivot at x. So now this was our L, right? This was our L value. Now for this question, our L value has decreased. Our our L value has decreased. So as our L value has decreased, our FH value is going to increase, right? Our FX value is going to increase. As our L value has decreased, our FH value will increase because this component is going to be the same, right? Because this component is going to be the same, which is this was our weight, right? The weight and the perpendicular distance, because the weight is not going to change, right? This as a whole is going to be constant because the moment of this particular part will not change, because this is our weight of the door and the weight of the door will not change, and the center of gravity from which it is acting will not change as well, because the door is not itself becoming bigger or smaller. The door's size is like this, right? The door's size is like this. It is not getting bigger or smaller, right? So that's why it will be constant. As it is constant, if this value decreases, this value will increase. Up to this, I think no issues. Now, as this has been the same, another thing that I want to say is um, as our this weight is remaining constant, we can also say the vertical components will also remain constant. The vertical of x and the vertical of y, because this weight is equals to the vertical of x plus vertical of y. So basically, if the weight is constant, the vertical x and vertical y will be constant as well. So yeah, our vertical x and vertical y will be constant as well. Now let's figure out this formula, which was tan theta is equals to fh by fv, right? fh by fv. This was our fh and this was our fv. So when we use the formula tan theta, we used fh by fv. So now let's write tan theta is equals to fh by fv. If fh by fv, if our fh increases, then our tan theta is also increasing, right? If our fh increases, our tan theta is also increasing. So we can say our theta value is also increasing, right? If fh increases, our theta value is also increasing because our fv value is constant. As our fv value is constant. And for forces, this was fh plus fv. Now, if this fh value increases, and let's say from 37.5 it becomes 50, then as a whole our f will also increase, right? Our f value will be greater. So we can say our f will also increase as well as our theta will increase. So these are all the points of the Mark scheme. Now let's go through the question from the MS, from the FAQ sheet. In the FAQ sheet, they have written about x. This was the formula that we have written. Then when L decreases, our f sin theta increases, and our f cos theta remains the same, which was our vertical component. Hence, f increases and theta increases. They have written it in a very short way, but I have explained to you guys in real detail. So now tell me whether you guys have understood it or not, or you have any question. বলেন, আসলে বোঝা গেছে পুরোপুরি? একটু বলুন তো, নাকি অনেক কনফিউজিং লাগতেছে? আমার একটু
হ্যাঁ, সাইন থিটা ইনক্রিজ হইলে কি ভ্যালুটা ছোট হয়ে যায় না?
এফ সাইন থিটা ইনক্রিজ হইলে ভ্যালু ছোট হয়, ঠিক আছে, কিন্তু এখানে এফ সাইন থিটা নিয়ে আসলে আমি ব্যাপারটা নিয়ে না, এখানে আমার এফ সাইন থিটা ইনক্রিজ করলে কই গেল একটা। আমার যদি f sin theta বাড়ে, আমার fh এর সাথে আমি tan theta এর সাথে কম্পারিজন করতেছি, ঠিক আছে। এখানে ও f sin theta বলতে কিন্তু হরাইজন্টাল কম্পোনেন্টটা খালি বুঝাইছে, ও একটু ডিফিকাল্ট ভাবে বুঝাইছে। এটা মেইনলি fh লিখলেও কোনো সমস্যা ছিল না। fh would be the best possible writing আর কি, ঠিক আছে। মানে f হরাইজন্টাল বলা উচিত আর কি, f sin theta না। sin theta ও কেমনে বলছে, ওই যে উইথাউট দি অ্যাঙ্গেল দেখে আর কি, আর কিছু না।
আচ্ছা ভাই, ক্লিয়ার হয়েছে, বুঝতে পারছি।
বুঝছেন, f sin theta ও ভুল লেখছে ওই f কি। আচ্ছা, আপনাদের one thing that I want to say you guys is I have written the papers and their units, right? Don't look after the answers of these questions. Go through the answers from the mark schemes, because in the mark scheme they have written f horizontal, because f horizontal would have been the correct word right here. If you have written f sin theta, then you will lose the mark. So make sure you are just taking the questions from this FAQ, but memorizing the answers from the mark schemes, which will be, you have to go through the mark scheme as well. Okay, you will have to download the mark scheme and then go to the mark scheme whether the mark scheme's answer aligns with this answer or not. This f sin theta was completely wrong, so make sure you are writing from the ms, where the ms has written fh. Clear? The f sin theta increase means the theta value is decreasing. When the sin theta value increases, the theta value decreases. So the answer would have been wrong, so make sure you are writing fh. Okay, so this is the main concept. Acha, Mohidin, did you understand this part? Mohidin? Okay. Karo kono questions? If anyone have any question, you can ask me right now. Abdullah, did you understand this part?
Yes, I did.
Okay, very good. Now let's move forward to the next questions. So basically, you guys have understood this, and the next question is this one. No, not this one actually. It was okay. এই কোয়েশ্চেনটা তো পরে যাব। Maybe someone of you guys asked me regarding this question as well, right? না, এটা কি কোয়েশ্চেন করেন নাই, মেবি এটা ছিল না। এটা আছে, বাট এটা তো পরে আসবে, একটু পরে আসবে, পরে আসবে। আচ্ছা, এটাতে অনেকে কোয়েশ্চেন্স করছেন, আই ডোন্ট আন্ডারস্ট্যান্ড এটাতে কোয়েশ্চেন্স করার মতো কি আছে এটাতে। এটা তো একটা ইজি কোয়েশ্চেন ছিল। এনি কি বলছে, the question says an object of mass m is resting on top of a spring. Okay, the spring is compressed a further distance x by a vertical force. The force is removed and the spring returns to its original length as shown. So basically it was like this. Okay, it was like this, and when you compressed it, it became like this, and then when you removed the force, it again become like this, right? So when something has been compressed, there is elastic potential energy right here, right? When you compress something, there is elastic potential energy stored in that spring, and when you will remove the force, this spring will immediately go back to its original position. So when it will go back, it will accelerate back, right? And as it is accelerating back, it is also getting some height, right? Let's say this height was 5 meters and this whole height is 8 meters. So he has gained some height as well as he was accelerating, or there was velocity with which he was going back, right? There was velocity with which he was going back. So we can write elastic potential energy converted into the kinetic energy, because he was accelerating, or there was velocity with which he was going back to its original position. So there was velocity, and this velocity corresponds from kinetic energy. And where did they get the kinetic energy? They have got the kinetic energy from the elastic potential energy stored. This elastic potential energy was stored, it was transferred to the kinetic energy and the gp, the kinetic energy, because it was going back to its original position with some velocity, and to gp because it was gaining some height. The formula of being half fx is equals to half mv squared plus mass into gravity into height. This was a very easy question, but still some of you guys, maximum of you guys messed up in this part, especially maybe এলহাম মেবি এটাতে প্রবলেম ফেস করছিল। এলহাম তুমি ফেস করছিল না নাকি ফাত্তা? Why did you guys? আচ্ছা, কারো আপনার কোনো প্রবলেম আছে? এই প্রবলেম ফেস করছেন, লজ্জা পাবেন না, বলেন প্রবলেম আছে কি?
ভাইয়া এখানে প্রবলেমটা এটা ছিল যে ওখানে একটা কোশ্চেন বলছো, একটা স্টেটমেন্ট দিছিল যে del x becomes 0 when the object has a vertical speed. তো del x টা তো কম্প্রেশনের জন্য, del x যেহেতু তো কম্প্রেশন করছিল ওই সময় del x টা, আর যখন মানে উপরে চলে যাচ্ছে একটা হাইট রিচ করতেছে ওই del x, এটা দুটো ডিফারেন্ট জিনিস হবে তাহলে?
না, আপনি del x দিয়ে বুঝেন না। del x দিয়ে কি বোঝাচ্ছে? del x মানে সবসময় এটা বোঝায় না যে let's say this is bigger, this is the size, if you increase its size, শালার বেটা তো শালা গেল। This is the size, হ্যাঁ? এখন আপনি যদি এটা বড় করেন তাহলে যে আমার শুধুমাত্র ডেল এক্স হবে এমন না, তার নর্মাল সাইজ থেকে যদি আপনি আপনারা ছোট করেন, if you make something smaller, this is also called del x. And now when you are taking it into its original position, the del is changing. Let's say the size was like this, you made it smaller, so let's say del x is equals to 5 now when you made it smaller. Again আপনি যদি এটা আবার একই সাইজে নিয়ে যান, then del x is equals to 0, right? Because it has gone to its original position. When it says returns to its original position, that means at that time the del x is 0. Del x doesn't means যে আপনার এই সাইজ থেকে খালি বড়ই হইলে del x আসে না। Del x মানে কি? Del x means change in length. Change in length can be bigger and smaller both. এবার ক্লিয়ার তাসফিয়া?
জি ভাইয়া, তাহলে যখন আমরা বলতেছি যে ওয়্যারটা উপরে চলে গেছে, মানে যখন কাইনেটিক এনার্জি বাড়ছে তখন তো একটা ওভারঅল ওয়্যারটা একটা হায়ার অ্যালটিটিউড রিচ করছে, তাহলে এর জন্য জিপিও হবে।
অ্যামপ্লিটিউডের কারণে না, ও হাইট তো রিচ করছে তাই না? ওই যে এখানে এই জায়গা ছিল যখন ওর এই যে ইলাস্টিক পোটেনশিয়াল এনার্জি আসিল, তখন ইলাস্টিক পোটেনশিয়াল এনার্জি 50 জুল আছে। এখন when you remove the force at that time, it will be uncompressed, right? It will be uncompressed. So where will this electric potential energy will go? When it is uncompressing from being compressed, this elastic potential energy will decrease and it will be converted into kinetic energy and GP is stored. So basically elastic potential energy has been converted to kinetic energy, that's why it is accelerating. And GP, that's why it is gaining some height, right? It is gaining some height. Now the object is at a higher position from what it was previously, that's why it was gaining. It was described the energy transfer. The energy was transferred from the elastic potential energy store to kinetic store and GP store. Clear?